Hello Matrix, and welcome to another video, and we are going to be dealing with some this thing must just go away, go somewhere far. Okay, welcome guys to yet another video, and this time we're going to be looking at the trial paper for maths that was written in Mpumalanga. This was a request by Caroline, and I hope, Caroline, you've tuned in and that you're going to enjoy the lesson. We'll try and go the long road to freedom here. I just hope it all goes well. It's my first time using the electronic device. It's actually my phone, so I'm working on a bit of a narrow space, so it's a bit challenging, but I hope the resolution will be better. Otherwise, guys, welcome to the new subscribers. I can see we are really pushing, and I would advise you to use this channel to your very best of ability. There is quite enough for you here to learn and to advance in mathematics. Otherwise, you can share this to the grade 11s who are going to become matriculants next year, and they too can find this resource quite useful, as of course a complement to other resources even on this platform. Okay. Now guys, we're going to be looking at question 1. It's a standard solve for x type of questions, so we're just going to jump in and start working. So 1.1, we'll probably need another color here. So 1.1.1, we are given a quadratic here, x squared minus 10x equals 24. Okay, so this trinomial is not in a standard form, so you always arrange it so that it is in standard form before you can start working. So we transpose the 24 to the other side, and then we leave 0 on the one side. Now it's in standard form. We can attempt to factorize. Usually factorization will work for this first time question, but it's not always. Be careful. At times they won't even tell you correct to 2 decimal places. Remember, the general instruction says whenever necessary, leave your answers into 2 decimal places. At times you may find that this expression is not exactly factorizable, so you may need to look into using your quadratic formula even without being told. So don't always think it's always going to be the second question. So let's look for factors that will multiply to minus 24 and add up to minus 10. So that is going to be a plus 2 here and a minus 12 on that side. Okay, so therefore our x is going to be a 2, or our x is going to be a 12. Sorry, this is a minus 2, not just a 2. Okay, so whenever you see solutions like this, you always test them by putting them into the original expression, and of course you check whether the left hand side will equal the right hand side. I mean, the original is that one, but again this one is harmless because it is just nothing but 24 transposed. So you can substitute even in that one and see if you're getting zeros on either side. So when I substitute my minus 2 there, I get a 24. And when I substitute my minus 12, I still get a 24. So that means the left hand side is equal to the right hand side. And this means these solutions hold. Okay. Of course, looking at those marks, you're getting marks for factorization. And then you're getting those extra marks for your answers. Okay, so let's go to 1.1.2. Now this one says we are to solve correct to 2 decimal places. Already this one is a leading question. It already tells us that we are to employ either completing a square, or so basically we can either solve this by completing a square, or we can solve it by using the quadratic formula. So this is simple, but again, it's not in standard form. So you always try to place it in a standard form first. So minus 3x, which is going to be equal to, you fold this one out, we get 9 minus 3x. Okay, so this is fine. So you see here, this minus 3x is the same as this minus 3x. So once they are the same on either side of the equation, they will simply cancel. Okay, so all we have here now is a difference of two squares. 2x squared minus 9 is equal to 0. Okay, and then of course, what can we do with this one? Very easily, we can say this implies that x is equal to minus b plus or minus the square root of b squared minus 4ac, all of that over 2a. Okay, that is just the general quadratic formula. Then we substitute here the 0 because there's no x term there. Plus or minus, and then here we have 0 squared minus 4 into 2 into minus 9. Okay, and then of course we do our thing. Oh, what am I doing? Okay, so that is the story. So we can, I mean, it's always safer to simplify this thing, but I can take a chance at this point because I can see I'm going to run out of space very quickly. So we just do that on the calculator. So basically I have the square root of minus 4 into 2 into minus 9. This is all divided by 4. So my first answer is going to be a minus 2, 1, 2, or a plus 2, 1, 2. Remember, we said it was a difference of two squares, so it will always be more or less the same thing, but one is negative, one is positive. Already this answer tells me that it's going to fit. And then of course, if you substitute this one back into the original equation, or this is the one here, you decide whether the left hand side is equal to the right hand side. Let's just go ahead and do it. So we've got 2 into minus 2, 1, 2, and then we're squaring that, minus 3 into minus 2, 1, 2, and then let's see. I'm getting a 15,3488, which is effectively 15 to the nearest integer. So I'm getting 15 to the nearest integer on the left hand side. Okay, this is the original expression over there. And let's see what happens when we multiply this 3 into 3. And then here we're going to say minus minus, which is going to be plus 2, 1, 2. So what I'm getting here is 15 as well to the nearest. So basically the left hand side is equal to the right hand side. You can check the other factor. We really don't want to waste too much time there. But I think here the marks, my correct is not the best. Okay, so that is the mark over there. The correct substitution is always a point to mark. So this is where you get those 4 marks for this question. Okay, let's keep moving. So we have 1.1.3. So what do we have for 1.1.3? It is our lovely inequality, quadratic inequality. It's already nicely factorized, so this makes our life a little bit easier. So once it is factorized like this, well, once I have those binomial factors, I already know that I'm going to put this into my algebraic table. It's essentially an arithmetic table adapted to algebraic expressions. And then of course here, the idea is to separate these factors. And then of course we get the critical values and put them in ascending order. And then we get the product of those brackets. So here we have the product. So let's just choose another pen so that we can work it out nicely. Now if we look for critical values here, we're going to get 1 and 2. You always put them in ascending order. This is when you equate this bracket to 0 and you solve for x, and then you equate this one to 0 and you solve for x. Now you ask yourself, for which x values will you get that binomial being 0? It will happen when x is 1, because it's going to be 1 minus 1. Okay, when you put a number greater than 1, say 1,5, that one is going to be 1,5 minus 1, which gives us 0,5. But what is the sign there? It's positive. And then when you put a 2, you're going to get a positive sign. A number greater than 2, you get a positive sign. Once one side is established as positive, obviously the other side is negative, because this is following a number line. Okay, when will this binomial, for what x values will this one be 0? When x is 2. Right? And then of course, if you put a number greater than 2, you put a 3 there, you get a negative sign. And then of course, if one side is negative, the other one is going to be positive. But you always make sure you double checked, okay, so that you don't make errors. And then now what is next is to do this. This is the critical step, which is that product, which is those brackets. So you say minus multiplied by plus is a negative. 0 multiplied by any number gives us 0. Positive multiplied by positive is a plus. And then plus multiplied by by 0, that's going to be 0. And then that product there is going to be negative. Now, where are our solutions? We want this product, which is this portion here, this last row, to be giving us a negative number. So when are we getting it? Well, we always consider our critical values. This thing. Consider the critical values, but it's not included, so it's an open circle. So we're going in the negative direction there, and then we're going to consider that critical value. Okay, and then we're going in the positive direction over there. So you can tell that when we're going that way from 1 that way, we're getting a number less than 0 for the product, of course. And then here, when we're moving from 2 to the right, we're getting also a product that is a negative number, which satisfies our inequality there, because this is the guy we have to satisfy. All right, so what does this tell us? It tells us that we can make our conclusion now and say, therefore, our x must be less than 1, or our x must be greater than 2. Okay, and then of course, some of you may entertain this sort of like domain type of writing it, or the intervallic notation. So this is going to come from negative infinity to 1. And both of them are not included. You're saying union. Oh, my union looks terrible. Then you're going to start from 2 to positive infinity. So why is it allowed? Because I know that x here in this expression, it's a quadratic expression, so x is an element of real numbers, so it is acceptable to use that. Okay, so of course the other way you can solve this, folks, is to remember, first of all, what is critical here? What is key is that this x multiplies there to get you what is going on. So when you multiply that x over there, you're getting a minus x squared, okay? Why are you interested in this? You're interested in the sign because you want to know what kind of a quadratic is that. So it is the one in which a, which is the coefficient of x squared, is negative. Then you want to do this graphically. Okay, let me just move this one a bit closer to the side. Wow. It's already doing its own thing, meaning this was already there. So anyway, so if we draw our what you call, this thing, Cartesian plane, that is the x, of course, that is the y, and then that is the origin. And you can already tell that, well, if you want the y-intercept, you simply multiply the minus 1 to 2. So it means at minus 2 somewhere, this graph is going to cut, and then at 1, it's going through, and a 2, it's also going through, because those are the critical values. But now that sign of a being negative over there, already it tells us that we have a grumpy face of our parabola. Okay, so this is a parabola that is doing something like this. Okay, so it's already doing stuff like that. So I'm just going to try and give you some shape there, but yeah, it's not good, but I'm just trying. Okay, so we have a parabola like that. So that means if you didn't know how to use the algebraic table there, you can simply put it onto the graph, but make sure you don't really waste your time here and try and look for these other terms here. I mean, you would still have your standard quadratic there continuing, but what you're interested in is the characteristic of, or the shape of that graph. 2, you already have your critical values there, so don't sweat. Now you ask yourself, when is this graph less than 0? Meaning, when is the graph appearing below the x-axis? You can see from this value right here and that value right there, and they are not included going that way and going that way. So do you see, it's more or less the same thing. So this is the feasible region for our inequality, and that is also the feasible region for our inequality. So basically from 2 that way, from 1 that way. And of course you can make the same conclusion as we have. Either you put it in an inequality form, or you can put it in the intervallic form. So the question is, this was 3 marks. Of course, you're getting a mark for that, and then of course for the tool that you used, okay? Or you can get a mark for your graph, depending on what tool you used. Remember, the instruction says everything that you've used, be it a table, be it a graph, whatever, please make sure you show it. Even if it is just a statement, make sure you write it down as a reason for saying certain things, because that is enough to stand for the explanation and logic behind what you're going to eventually do. Okay, so this is how you get these 3 marks, guys. And then let's look at the other question there. So we have 1.1.4. Oh, don't move too fast, mister. So 1.1.4. So we're getting here a 4 to exponent x plus 2 to exponent x equals, what is the story there? Equals 8 into 2. It is equal to 8. My 8 looks hungry. 8 into 2 to exponent x plus 1. Okay, always analyze these things. So you look at this, you see you have 2 terms on the left hand side, and you have 2 terms on the right hand side, but they're in a factorized form. So what if we do that and we get something like this? It's possible, right? So that is the key to how you handle these exponential equations. So this implies, you say, well, this is 2 to exponent 2 or 2 squared, and then that simply multiplies the x. So you get 2 to exponent x plus 2 to exponent x. Sorry, this is 2 to exponent 2x equals 8. We leave this one alone because we think we might just be able to find a link to deal with the situation. And then of course you're like, hold on, I still have a rule that says if I have x and x, it means it must have been 2 to exponent x multiplied by 2 to exponent x, right? Right. And then of course I'm adding 2 to the exponent x there. That was a standalone, which is 2 to exponent x plus 1. Okay. I'm sure you're paying attention there that I'm saying 2 to exponent x. I'm not saying 2 to the power x. There's no such a thing. Of course, it's a, should I say, it's a universal error, because almost everywhere in the world you go, you'll find people saying 2 to the power x, which is unfortunate. I mean, well, there are misnomers everywhere that don't mean anything at all. In fact, sometimes they just, nullify the entire thing, but they have been accepted as such. But yeah, it's not a problem. But the power is the whole expression. That means a base and its exponent. that is a power. So you can't say 2 to the power x. That just doesn't make sense. You can say the power of 2 to exponent x. That is correct. Okay. Anyway, just trying to teach you a bit of maths there so that you can use correct references here. We don't want weak mathematical students who say things that don't make sense and then they are thinking that they are making sense. Okay. Not a problem, guys. I'm just being who I am, I'm just too particular about things. Of course, when there's no clear light or clear darkness, you're in the gray zone, it's fine, but this is not the gray zone, okay? Because even if you look at the rules of exponents, they don't talk about adding powers or multiplying powers when you're referring to exponents, right? Right. Anyway, we can already see that, hold on, we do have this term and that term. It looks the same, so it's a factor. So we can actually get rid of this relatively complicated binomial. It's not too difficult, but at this point, we can just do away with it. So that one will cancel that, and that one will cancel that. And then we remain with 2 to exponent x equals 8. And then we're like, hold on, this is 2 to exponent x equals, and then you look at that base. Can you express 8 in terms of a power that has that has a base of 2 to some sort of an exponent? Yes, we can. It's 2 cubed. And then, of course, here you have 2 powers, that is 2 to exponent x, and you have another power there, which is 2 to exponent 3. So a power is the whole thing, right? But now what is common about these 2 powers? They have the same basis. And therefore, what does that mean? It tells us we can drop we can drop those bases and take the exponents. All right. Not a problem. So that is the answer. Okay, this was a 6-mark question. So you may be wondering, where is the mark? Of course, changing that 4 like that is important, and splitting it like that is also important. You can already see here we've been literally working on the 1, and then to factor out, I made an error here. Oh yeah, no, it's not. This is a 2, but it looks a little bit hungrier. This is 2. So factoring out that 2 is important. And then, of course, the whole operation here. Let me see how many marks already before I overlay. 1, 2, 3, okay? All right. And then, of course, this whole operation here is important, that dividing stuff. So you get the 4th mark to change that 8 to 2 to exponent 3 is important, and the final answer. Again, this is an equation. You check whether the left-hand side is equal to the right-hand side. Okay, now let's do it, the original one. So 4 cubed is 64, right? And then we're going to add here 2 cubed is 8, right? So this gives us 72. So the left-hand side, I have 72. So I have 8 into 2 cubed plus 1, okay? And then I'm getting 72. So the left-hand side is equal to the right-hand side. So there's no way I'm losing these marks. So make a habit of treating algebra the way it is. Remember, things need to make sense for you to accept an answer. All right, let's look at this one. Solve for x and y simultaneously. Okay, not a problem. So usually what is important is to pick on this equation, the simplest one, and then you start working further. So you know that from here it will imply that x is 3 over 2y, okay? You can say this is equation 2, and then maybe this one saying it's 1, okay? And then the next story is that you can say put 2, what am I writing there? You can say put 2 in 1. Okay, what do we get? So where you see x, you put 3 over 2y. So we have here already 3 over 2y, and then all of it squared, minus y squared equals 1. Minus 2, instead of x, you put 3 over 2y, and then we add y. Okay. So that is what you do here. What does this imply? You first fix this one. So you distribute the exponent to the coefficient and to the variable. So this is going to be 9 over 4. Oof, that 4 looks a little hungrier. Okay, y squared minus y squared equals 1 minus, okay, here you can already see that when you're multiplying, those two cancel. So we remain with 3y plus y. Okay, so what I do here to just simplify my life, I just make sure that everything is in a fraction form. And then I know that my common denominator here is 4. Right, because 4 can accommodate itself, it can accommodate those ones. That's why it's the common denominator. But technically speaking, it is the highest common denominator of all these denominators we see. So to say LCD is another issue that, well, it's okay. It can't be too much, but I think if you really are a maths fanatic, you will not accept wrong inferences and accept them as correct. But it doesn't matter. So if you multiply by 4 throughout here, we get 9y squared minus 4y squared. This is a 4 equals 4. I don't know, man. Sometimes things just like to mess things up a bit for me. So this is minus 12y plus 4y. Okay. Now we have a nice linear quadratic here. So this implies what? 9 minus 4 is basically 5y squared. And then here, these two will sort each other up to get a minus 8y. When it comes this side, it becomes a plus 8y. Then we transpose the 4, we get a nice quadratic in standard form. So this implies we can factorize this thing. Almost always it will be factorizable. You will hardly have a situation where you are forced to do the general quadratic. But I mean, whatever works for you, you can apply it. But it's a lot of work to go the quadratic way. But at the same time, it can be technical if you're not smart about how you choose your factors, because there are plenty of factors at times. But if I choose a 2, I know 5 by 2 will give me a 10. Then if I subtract a 2, I'm getting an 8. But now I want the bigger factor to have, the bigger product to have what you call a positive sign, or the sign of the middle term. And then this one will have the sign of the last term. Okay, not a problem. So that is sorted. So what does that mean? It means my y is going to be 2 over 5, or my y is going to be a minus 2. Okay, that is sorted. Now, once we get to this stage, what can we do? We can make a conclusion that our x is going to be, we substitute into that, it's going to be 3 over 2 into 5 over 2 this time around, okay? Or our x is going to be 3 over 2 into minus 2, okay? So you substitute the y values into that. You can stay substitute, but if you've already found y, this already implies what you're going to do. And then we sort this one up, so you can already tell here that, hold on, what is the story there? Why do I feel like something is not quite? Why does it feel wrong? Heaven, what is going on? I didn't get something like this. Yeah, I wrote this one wrong. I can tell, man, something is just not adding up, because what I got is not what I am putting in here. I'm wondering, where did I get this 5? This 5 over 2. This is 2 over 5. You see? Always double check, guys. At the very end of your thingy, you may have a few issues. Just double check. I was thinking, now where's this coming from? Hence, I said it makes no sense. So this is 3 over 5, okay? Or x, this one cancel there. You get a minus 3. All right? So this is the solutions for both x and y. And then, of course, you can take this x value and put it in your equation 2. You get 3 over 5. And then we say 3 over 5 into, say, 2 over 5. So the 2's cancel. Then we remain with 3 over 5. So 3 over 5 is equal to 3 over 5. So that's correct. To check this one, you put a minus 3 there, and then you put a minus 2 there. The 2's cancel. 3 times minus 1, it's a minus 3. So minus 3 equals minus 3. So this simply says these solutions are correct. Again, double check the solutions. Always check them on the simpler equation, so that you don't lose these 6 marks unnecessarily. So I'm not even going to go into where those marks are. Alright guys, let's get to this one quickly. Now it says the solution of a quadratic equation is given by, okay, we can see that this is the root using the general quadratic formula. It's minus 10 plus or minus the square root of 17 minus 2p, all of it divided by 5. And then now the question says, determine the largest integral value of p for which the x values will be rational. Okay, so this is basically a question on the nature of the roots. So the question is, when do we get rational roots? So when do we get rational roots? You know very well that, well, the roots, for them to be rational, it means the discriminant. We can just say for rational roots, it implies that the discriminant delta must be greater than or equal to 0. Okay, this is a bit problematic when you say greater than 0, because there are numbers greater than 0 that are irrational. So that means it has to be a perfect square when it is greater than 0 for it to give us rational roots. Okay, now that can be a bit technical, but at the end of the day, if those numbers are still there, this sign accommodates for those numbers, but equal to 0 is a bit safer, but you may feel like you are not quite correct. So what does this mean? It means our discriminant is greater than or equal to 0. And where is our discriminant in our question? The discriminant is what is under the square root sign. So they've already sorted that discriminant for us. This implies that 17 minus 2p is greater than or equal to 0. Okay, not a problem. And then what do we say here? We just solve this linear inequality. Honestly, 2p is greater than or equal to minus 17, and then we divide by minus 2. That one cancels. So what do we end up with? We get p. Remember, when you divide by negative or multiply by negative, it affects the inequality sign. So it becomes 17 over 2. But now hold on. They said the greatest or the largest. Remember, this is already a max. The max is 17 over 2 or any number less. We can get rational roots. So this is what this means. But now we wanted the largest value. So the largest value here will become that 17 over 2. Okay, that is your answer. Okay, so do you see, this is nice, because when you say less or equal to, it means the maximum or the biggest is going to be 17 over 2. So when you do this, sometimes it needs a bit of bravery, because you may not be convinced you're choosing this right. But if you chose the safe route and said discriminant must be equal to 0, it will work out just like that. Okay, not a problem. But you wouldn't be convinced that this is the largest. But if you do it this way, now you get to see that, okay, I'm probably in the right place. Okay, so basically here, this substitution is quite important. And literally, I think this is important in the answer. And in fact, not this one, the mark is here for the substitution. So I hope you guys enjoyed that one. That is how you can get through question 1 and take down those 25 marks. Okay, let's move on to sequences and series. All right, what do we have there? Now for sequences and series, but actually I'm not seeing very clearly. I think I need a bit of light. Let me just put light, but of course it doesn't affect your light, but it affects my light here. All right, guys, let's just do this thing nice and easy. Okay, so what is the story here? The story here says, given a quadratic sequence 1, 4, p, 22, and 37, and then of course it goes on and on. It says now calculate the value of p. Okay, so let's sort this one out quickly. So 2.1.1. We know that our quadratic sequence is basically 1, 4, p, 22, 37, and whatever is going on in there. Okay, so how do we do this? We always have to consider the first differences, because remember, the characteristics of a quadratic sequence is that it gets what we call first differences. So 4 minus 1 gives us 3. And then p minus 4 is just p minus 4. Okay? And then 22 minus p is going to be 22 minus p. Okay? So that is a sequence on its own. And then, of course, that one there, 37 minus 22 is 15. And then, of course, it goes on and on. Alright, so this is very key, because for us to solve that p, we know that, well, from here it implies that p minus 4 minus 3 is going to be equal to 22 minus p minus into p minus 4. The reason is that we have a common difference of that sequence. So you can say common diff, or you can use the small letter d, which is what is usually used to denote that common difference, okay, or constant difference, as they say. All right, so let's keep going, guys. We're almost there. So we just sort out this thing. It's going to be p minus 7 equals 22 minus p plus 4. Okay, so this tells us that this is minus p minus p. So these will add up and give us a minus 2p, which when you combine with that one, when you finally transpose, we get a 3p is equal to, and then we have to work out what that will be. So this becomes essentially 33, right? And then it tells us that our p is going to be 11, right? Just confirm, you know, when everything is moving smoothly, you always want to make sure you double checked it. So that is the value for p. Again, you are getting 3 marks. What is important here is to get this situation, and this statement is important because it aligns everything. And then, of course, you get the answer there. The substitution won't really count. Or they may say for substituting, but it doesn't really matter. We have what they want. Okay, great stuff. And then now let's answer the next question. It says now, 2.1.2. It says now, if p is 11, which shows that this is correct, determine the general term of the sequence. Okay, not a problem. So all I know is that now we have our sequence. The original sequence is looking like this. It's 1, 4, 11, 22, 37, and on and on. And then we have ourselves our first differences that are going to give us, when you take those 2, you get a 3. You take those 2, you get, what is that, 7. When you take those 2, you get 11. Take those 2, you get a 15. Okay, so this is a sequence on its own. And then, of course, you also have to consider second differences. Okay, maybe let's use another color. We have a few of them colors here, so we can play around them. The second difference is here. This is going to be 4, 4, 4. Okay, you can see that it is definitely constant. Oh, it doesn't look like I have space. Okay, guys, not a problem. What I can do here is to probably remove a portion of this. I no longer need it. Everything that I need is already with me. So you have seen how it works. So I'm sure you guys are not going to complain too much. All right. And then, of course, this answer belongs there. All right. Not a problem. I'm just trying to create a bit of space, guys. Nothing major. Okay. So we know here that this implies that 2a is 4. Okay. And then if we solve further, a is going to be equal to 2. Right. Which also implies that 3 into a, which is going to be 2, plus b is going to be equal to that very first difference there, which is going to be 3. Okay. So this is going to be 6. When you transpose to this side, it tells us that our b is going to be a minus 3. Okay. Which also implies that what? A, which is 2, plus minus 3, which is minus 3, plus c is going to be equal to the first term, which is 1. Therefore, c, remember this is going to be minus 1. When you transpose to this side, it becomes a plus 1. So c becomes a 2. Okay. So if we try and work through here, you can say therefore Tn is going to be 2n squared minus 3n plus 2. Okay, that's the answer that they wanted. Okay, and then you can double check here. How do you check? You just say my T1, for example, is equal to 1. So you just say T1, you put a 1 in there and see if you're going to get 1. So this is 2 into 1 squared. Oh, what did I write in there? 2 into 1 squared minus 3 into 1 plus 2, and then it gives me 1. Okay, let's take another one and say this is 1, 2, 3, 4. Let's say the fourth term. Let's just say, what is the fourth term here? The fourth term is, the third term is 11. Okay, let's just put 3 in there and see if we're going to get 11. If it counts, then we know it's correct. So what I'm getting is 11. So this means this is correct. So please, when you have a sequence, double check that this represents each one of these terms, or else you are going to just lose marks unnecessarily. This thing is easy. There's no need for any loss of marks. Okay, let's keep going, guys. So here we have ourselves a question. Let me see. Did I answer everything? Yes. So now we're looking at 2.2. So I copied it here. So 2.2 says, an arithmetic sequence and a geometric sequence are combined. What have we combined here? It's an arithmetic sequence. Whoa, come on. And a geometric sequence. So they are put side by side, basically. Whenever they are combined, they get put side by side. Okay. So you have to be able to recognize that are combined to form the following sequence of numbers. Now we have to explore these numbers and say, fine, if we focus on the odd sequence, for example, because it's always going to be odd and even, right? Let's get a color that can work for us. So if we're looking at the odd sequence, the first, the third, the fourth, the fifth term there, those are the odd numbered pattern or number pattern, whatever. Let's establish what is going on there. If you say 6 divided by 3, you're getting a 2. 12 divided by 6, you're getting a 2. 24 divided by 12, you're getting a 2. So this means the odd numbered pattern is an as. Okay, so we can say the odd sequence, so 2.2.1, we can say the odd sequence is what? Geometric. Yeah, that's geometric. So it's a GS with R equal to 2. So these are the things you just want to work out quickly. And then of course you can say the even sequence, yani seqale khona lokho. The even sequence is an AS, because they said already that it's a GS and AS. So sometimes you can just work fast with D equal to, you look here, let's look at that sequence and be sure that we understand it. So this, that, that, and that. So guess what? When you say 11 minus 6, we're getting a 5. 16 minus 11 is a 5. 21 minus 16 is a 5. So this is basically giving us a 5. Okay, maybe my 5 looks a bit hungry. Alright, so that is fine. And then, what do we want to do then? We can already tell that, well, let's see. We said here, the even sequence, remember it ends with the even one. So the next term is of the odd sequence, which is the GS. So you just multiply the 24 by 2, we get 48. So you can just say the next terms are, it's going to be 48. And then the next term is that of the odd sequence, right? Sorry, no. Is that of the even sequence. It will follow. And then, of course, we just add 5 to 21. And then we're getting 26. And that's it. You are sorted. Of course, the idea is be able to work out things. Of course, they just said write down. So all of this is what you would do on your rough work to get an idea. And then, of course, you start sorting things as they are. And this is the answer. So you get your 2 marks there. Then you move on. Okay. 2.2.2. They're saying now calculate the sum of the first 40 terms of the sequence. Okay. So that's not a problem. So we can answer this one this way and say S40 is going to be S20 of the even sequence. Okay, let's just say S20 of the, say, GS plus S20 of the AS. Okay, arithmetic sequence. Well, this is fine because it makes sense. Why? You think about it. You choose an even number of terms. Always choose from what you have. If you say 1, 2, 3, 4, you just pick this situation. Let's just take this one up to here. So you pick those 4. And then you count how many of each are there. There's 2 of the odd, there's 2 of the even. So if it is 40, it's going to be divided into 2. So always do that. Don't use big numbers. They will confuse you. Just choose the small number and investigate what is going on. And then you just work your magic after all. And then of course, we're going to have here, maybe let's start it a bit back here. This is going to be equal to, this is, of course, we said that is the GS. So GS sum of 20 terms is going to be what? A into, remember we found that our R was 2, which is greater than 1. So it's going to be R to the exponent N, which is basically 20. Maybe let's just write that. Let's just write the formula first. Minus 1 all over R minus 1. Then we add here N over 2 into, and then of course we're just going to say 2A plus N minus 1 times D. And then we substitute. So A for the geometric sequence is the odd numbered pattern over there, so it's going to be 3. A is the first term. We found out that, well, the common ratio there is 2, so this is going to be 2 to exponent 20, because we're saying that 20 times there minus 1 all over 3, wait, that is 2 minus 1, then of course plus. Here we're going to have 20 divided by 2 into 2. Now the first term there of the even was a 6, plus 20, my 20 doesn't look alright, 20 minus 1, we found out that this is a 5, right? Okay, so let's get the values there without causing ourselves any problems. So I'm going to have here 3 into 2 to exponent 20 minus 1, close, divide by 2 minus 1, which is just 1. And then I'm adding here a 20 over 2, which is literally 10, into, now this is going to be 12, right? 12, sorry, plus, and then this is going to be 19 times 5. Okay, so is that correct? It looks all right. So let's see, what do we get? So I'm getting 3,146,795. Of course, when you get big numbers like this, it can be quite technical, all right? So you just want to make sure you simplify this side alone and that side alone, and then add eventually, because there's a very big chance for errors when you put things together. It sounds simple, but it's very complicated. So again, the most important thing here is the approach rather than an actual answer, because you are practicing, but you need to exercise your meticulousness as you solve these things further. All right, so now we're told here, write down the sum of the first 40 terms in sigma notation. All right, so what do we do here? So this is 2.2.3. So basically for the AS, right, we know that Tn, we need the nth term there. Tn is going to be A plus n minus 1 times D. A there for the arithmetic was a 6, 6 plus n minus 1 times 5. When you solve this further, we're getting 6 minus 5, which is 1. So it's 5n minus 1. Okay, that is fine. And then, of course, what else do we want? We also want the GS. The GS here, Tn is equal to ARn minus 1. A is a 3, and then the R was a 2, and then n minus 1, and that's what it is. And then we can say, therefore, the sum of all these 40 terms, right? The S40 is going to be equal to the sigma, where n is equal to, we're starting with n equals to 1, up to 20 terms at the top. Now we can decide, what did we say? We started with our GS. So we can start with our GS of 3, 2 to the exponent, 3 times 2 to the exponent n minus 1, plus the sigma, say here, we can choose any other letter of k, say k equals 1, up to 20 of 5k minus 1. So we are sorted like that. So our S40 literally looks like that. So this is very easy, guys. I'm not going to even overly emphasize that, so you get your 3 marks. Of course, what is important here is getting these terms the nth term, and the nth term over there, and then of course the final answer. That is where you get your 3 marks, where you represent these two in sigma notation. Okay, let's get to the next question quickly. It says now, calculate which term of the arithmetic series. Again, you're being told what it is. So always make sure you understand what you're given. So it's minus 49, minus whatever. So here, guys, I'm just going to work fast here. What is the difference between these two? It's a plus 3. And you can tell that it's a constant thingy there. So I have that. So it says now, calculate which term in the AS will be the first term greater than 25. And remember, that is the value. That is the value. So which term? Remember, terms are natural numbers, so you can't take a decimal. So that is the idea. Okay, so we are saying here Tn, we want it to be greater than 25 in terms of value. Okay, so which term will be like that? Let's see. Tn in an AS is A plus, okay, maybe let's do the thing properly. So this implies that A plus n minus 1d into d must be greater than 25. And then what do we know? Our A is minus 49 plus n, we don't know. D is 3. Okay, must be greater than 25. And then this also implies that we simplify minus 49 plus 3n minus 3 greater than 25. So these ones sort themselves, they sort themselves out. We have 3n greater than, so 49 plus 3, that is minus 46. And then of course, when it crosses over, it adds to the 25 on this side. So I'm getting 71. So 49, it becomes, I'm making a mistake here. This is a minus 3, so it's not like that. So this is minus 49 minus 3, it's minus 52. So we add 25 to that, it becomes 77. Okay, this implies that our n is going to be greater than 77 over 3. What is that? So this is basically 25,666. So if we look at this one, let's just say, therefore, okay, let's just write here n is greater than 25, say 67. So we know that this is an element of natural numbers. So if we're looking for something that is going to be greater than 25, and we're getting 25 for n here, 67, so the nearest here is literally going to be 26. Okay, so to the nearest integer, that should be 26. Okay, so I'm hoping that makes a bit of sense, and we simply move on. So that should be 26. So that is just this correct substitution here. Maybe getting that and then eventually solving it properly. So that is it. We move on. So that was a simple one. Nothing major there. Now it says consider the series. Of course, you can tell, I mean, this picture is too small here, but you can tell that this is sort of like going to infinity. All right. So it's a sum to infinity. Now it says determine the values of x for which the series will converge. I mean, for it to converge, what do we know? We know that our r must be less than 1, greater than minus 1. That is the characteristic of a convergent series. So let's first sort it out and say sigma to infinity of k starting at 0 of x into x minus 4 into k is the same. We just expand here. When you put a 0 in here, this falls away because anything or any base to exponent 0, it's a 1. So we get x. This is a series, so we're adding plus. When you put a 1 in there, this becomes an x into x minus 4 plus, at least to 3 times. You put a 2 there, it becomes x into x minus 4 squared plus dash dash to infinity. So basically you can already see here that r is going to be x minus 4. Because if you take this term and divide by that, the x's cancel, you remain with that. If you take this and divide by that, the x's cancel, the 2 will cancel this 1, and then you remain with just that term. So we are saying here for a convergent series, it implies that r must be less than 1, greater than minus 1. This implies, what is r here? X minus 4 must be less than 1, greater than minus 1. Therefore, our x, so when you transpose this 4 to this side, it becomes a 5. Transpose this 4 to that side, it becomes a 3. So that is the values of x for which this series will be convergent. Okay, not a problem. Again, an easy 3 marks here. Finding r is key. And then, of course, substituting into this equation, and then the final answer is where you get those marks. Okay, let's look at this one. 2.5. Well, I'm happy that anyone who's been following my channel there, as in watching everything that is in there, will have smiled when they see this question, because I presented questions that are like this there. So it's as if there's people all over these provinces have been looking at that channel of mine. But I mean, it's just a coincidence. It's nothing major. Just a coincidence. Okay, so we're seeing 1 plus 2 plus 3 plus 4 plus 6. Okay, a jump plus 7, 79 plus 81. We're being told that it's a series of natural numbers. It's a series of natural numbers for which all multiples of 5, okay? Make sure you understand these things. Multiples of 5 have been removed. Now it says calculate the sum of this series. Okay, so what happened here? Now, you can already tell here that fine, for the original series, let's just say original. Yeah, I don't know, man. So let's say original. Bo, kwenze kantoni bo. For the original series. Okay. So let's say what happened in the original sequence or series. We know we have 1 plus 2 plus 3 plus dash 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 until the last term, which is 81. Okay, so this is important because we know this is the last term. It doesn't continue beyond 81. So we know that this is an AS with a common difference of 1, because the next term is just adding 1 to get to the next term. All right, and then of course, what is the number of terms? N here is 81, because you're just going to say 81 divided by 1, it gives you 1. Or 81 minus 1 plus 1, it gives you 1. All right, not a problem. And then let's see now, what is the series? Let's see the series of multiples of 5. It is such that we have 5, 10, 15, dash, dash, dash. And you know the last one here is going to be 80, right? because 81 is not a multiple of 5. So the last one is going to be 8. Let's write it nicely there. Okay, so that one is going to be 8. So what do we see here? Again, we can see that this is an AS with a common difference of 5, because 10 minus 5 is 5, 15 minus 10 is 5, and so forth. Okay, so this is what is going to happen. And then now it says calculate the sum of the series. So basically Sn here is going to be the sum of the 81 terms of the original, right? Minus the sum of, okay, I forgot to do n here. What is n here? N is going to be 8 divided by 5, which is 16. Okay, not a problem. So that's how you do that one. So they're going to be like that. And then, of course, you can go about it. The long root, say Tn is equal to this, and then if Tn is 80, you will see that at the end you're going to get 16. So you can go about it the long route. I've taught it very well in my videos there. So we're just going to go through it and say this is the S16 of the multiples of 5. Okay, I mean, you don't really have to write a specific formula. You can just show up with some things as well, but I always like to make things to make sense. So what is that? So this is n over 2. Remember, the formulae are important. I know the first term here, and I also know the last term. So I'm not going to bother writing a very long thing that is tiring. Minus, here's going to be n over 2. I also know the first term. I also know the last term. So I'm not complicating my life. Here there's 81 terms over 2. The first term is 1. The last term is 81. Ooh. Minus, this is, what is that? 16 divided by 2 into the first term is 5. The last term is 80. Okay, again, you can try and exercise a bit of caution here. Maybe let me just lead by an example and show what I mean. At times you just want to keep it easy. So this is going to be 82 there. So I'm getting 3, 3, 2, 1 minus. Then when I sort this one out, I'm getting 680. So it's easier now to be sure what you are doing. So I'm getting 2, 6, 4, 1. Okay, not a problem. So this is the answer you're getting there. So do you see the technique? Always have an approach, guys. And believe me, these things are hardly, explained in classes at times, because you can't fail to teach standards and then go and start fishing on some very crazy things. First, you want people to understand. But during your practice sessions, always try to do as much as possible. And use these YouTube platforms as a means to understand things in different angles, because I may present it in this way and someone else present it that way. At the end of the day, you're getting techniques that will save you in your final exam and actually simplify your life. Alright guys, so I'm not even going to bother here and say where the marks are. So that's it about question 2. Now let's run to question 3, my favorite section, because these are functions. Alright, again, this is the section where you want to pay the most attention because it carries a lot of marks. And you can see here we've been dealing pretty much with some things that look like functions throughout this paper. Okay, question 3 says, in the sketch, A is an x-intercept. Alright, now these are very key statements that you want in order. A is an x-intercept, and B is a turning point of the parabola. So basically A is an x-intercept of the parabola and B is the turning point of the parabola. and the parabola is given by the function f of x is equal to ax squared plus bx plus c. So they're giving us it in they're giving it in standard form. Not a problem. And then now they're saying a straight line AB. Do you see AB is still having intersections at A and B to the parabola, is given by g of x. Okay, maybe let's highlight it. It's important to keep it. Okay, so our g of x is 3x plus 6. So if we have an equation, it means we can work out, obviously, the constant is always the y-intercept. So it already tells us that B is the point 0 and 6. Okay, because we're picking it from that y-intercept. And then, of course, we can even solve the x-intercept and make this one 0. Transpose the 6, we divide by 2, we get a minus 2 here and 0. So do you see, you need to always analyze information as it is given, because if you don't, it's going to hurt. Then we're told D is that point, which is minus a third into 35 over 6. Okay, not a problem. And then is a point on F and CD is perpendicular to the x-axis. Okay, that's fine. If it is perpendicular to the x-axis, it means it's parallel to the y-axis. And if it is parallel to the y-axis, it means the x value at C is the same as the x value at F and the same as the x value at D. So that means the x values for those 3 points is basically minus a third. What differs is just the y values. Okay. Again, if this is a parabola and that is a turning point, if this is minus 2, this must be a 2. Okay? Because we know that that point should be equidistant from the origin to that, or at least the x-coordinate at the turning point. So we know that if we went 2 units to the left, we're going to go 2 units to the right because it's symmetrical about that line. Okay, guys, so not too much to say here, but more to do. So I think here, B is the y-intercept of F and G. Okay, we can see that already. Now let's start. It says determine. Now, see when a question says determine, you have to show us how you came about it. Otherwise, if you just show up with something, it's a problem. You're not following the instruction. I know it's easy to just jump in and write it like that, but why do you write it like that? All right, so let's go for it. 3.1. We want the coordinates of B. We can say B is a y-intercept of g of x. Okay, this implies that x at B is equal to 0. I mean, that is standard information. And then, of course, this is such that y is going to be equal to, maybe let's just do it this way and say this is such that g at 0 is going to be equal to 3 into 0 plus 6, which is just 6. Okay, we can say therefore B is that point 0 and 6. I mean, you may feel like you're just gonna jump in and write, because I mean, even if they give the memo at some point, it will come with just that without any further explanations. But they said determine. So when you determine, of course some situations don't allow you to explain, but this needs to be explained. And then of course just walking away with just 1 mark. Okay, 3.2. What do we have there? It says now determine the coordinates of A. Again, determine. A is an x-intercept. So we can say A is an x-intercept of G. This implies that y is equal to 0. All right. Which, okay, let's just not say too many things. Such that, such what? That 0 is equal to 3x plus 6. Therefore, x is minus 2. Therefore, A is the point minus 2 and 0. So do you see they said determine? Please show us. You get a mark for that and then for that. So do you see at times It's not just straightforward. When they don't say right or what, if the word says determine or show, please have a habit of showing. Okay, let's keep moving. 3.3 says determine the equation of the parabola in the form y. Okay, now we have the turning point. So we can just say y is going to be equal to a into x plus p plus q. We have the turning point form. Use it to our advantage. A into x. Now the x coordinate at that turning point is 0. So we just put a 0 there. And then of course I forgot to square that thing. And then q is just the y value, which is 6. Okay. So this basically tells us we have ax squared plus 6. Okay. So what do we do? Now we can use another point through which this graph passes, which is a minus 2 and 0, such that we have 0 equals a into minus 2 squared plus 6. And it follows that our a is going to be minus. Now when you put 6 that side and divide by 4, 2 goes 3 times to 6 and 2 times to 4. So do you see our a is negative? Did we not expect it? We did, because our parabola is a grumpy face. All right. So now we are sorted. We can say therefore y is equal to minus 3 over 2 x squared plus 6. So that is sorted. I mean, that's a bit of marks there. And then of course this correct substitution, and to get to this, and then this substitution, and to get to this is what is important. Perhaps we may not necessarily say this substitution per se, but maybe finding the value of a is quite a wonder. Alright guys, so the next one says calculate the length of CF. Okay, so I've already crossed over, so I thought I was going to need a bit more space, but yeah, I don't need to now. So calculate CF. So let's have a look at CF, just to see what is going on. If you look at CF, we said the x-coordinated f is the same as the x-coordinated d, is the same as the x-coordinated c. Why? Because that is a vertical line. But on which line does this f lie on? It lies on the line of g. So it means CF is going to be effectively the y value at f. You know? Very easy stuff. So you just go on and say, well, let's start it nicely. No. So 3.4. We can say here the x-coordinate at C is equal to the x-coordinate at F. Which is also equals to the x at D. Alright? Why are we saying that? Because CFD CFD is a vertical line. Not a problem. Okay. Which we know that therefore the x-coordinated f is going to be minus a third. That is what we want to conclude. Right. And then the next thing that we want to say here is that, well, this implies that CF is basically going to be g at minus a third. We don't want to waste too much time there. What is that? This is 3 into minus a third plus 6. What is that? So these two cancel, so we get minus 1 plus 6, which is 5 units. Okay, that is done. Easy stuff, eh? Very easy. What is important is establishing that x-coordinate. And then the substitution. Oh, doch, the answer. Okay. Looks like they're not interested in your substitution. But we can even mark it there entirely and say substitution and whatever. But yeah, that is it. 3.5. Let's keep moving, guys. Looks like we're losing time. Then it says here, a new parabola is obtained when the y-axis is moved 2 units to the left. Okay, so what happens when we move the y-axis 2 units to the left? It means our graph is going to be sitting, the turning point will just shift. Every other point is going to shift to the right 2 units, and that means our turning point is going to move to this new position. Maybe we can call it B prime. Now it's going to be -2 and 6, because this is the same as a horizontal translation to the left, né? Because every other point on this graph is going to translate 2 units to the left. So this is basically what they're trying to say, but they have very different ways of trying to trick you. And then this time they say write down, so you don't have to explain. So you can say the turning point, or you can say B prime is going to be -2 and 6. Done. And then of course you get your 2 marks here for that. Of course you already know what is going on, so you don't need to explain. Okay, great stuff. So they just wanted the turning point, not a problem. Now 3.6, they say a new graph of P is obtained when F is translated. Do you see here? F is translated 6 units downward. Okay, again, what is the line of questioning here? Write down. Okay, so now we know that, well, our P of x is going to be equal to f of x minus 6, right? Because we are translating this one down, meaning it's a downward shift. But what was the equation of f? It is that equation which is calculated above there. So it's -3/2 x squared plus 6, and then we're subtracting 6. This is effectively -3/2 x squared. Okay, that is fine. So we are sorted. They said write down. So you could easily show up with P of x is equal to that and not show us how you worked it out. This is what you could write on your rough work. Okay, great stuff. All right, folks, let us just keep going. And then what is the next story here? Whew, they were just giving you 1 mark for this. Come on, guys, that is a lot of work, man. Mucho trabajo there. Okay, 3.7 says determine the equation of the inverse of P, okay, in the interval x less than or equal to 0. It says write your answer in the form. Of course, the question says determine, but you are to write the final product in the form y is equal to da 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 da. So let's go 3.7. We'll start off like this and say find the inverse of P will be such that we have x is equal to -3/2 y squared. So you switch x for y. And then, of course, you solve for y again. This implies that y squared is going to be -2/3x, okay? This is the most important. You just simply cross multiply that and divide by 3, or you divide by this and then it flips around. Not a big deal. So therefore our y is going to be the square root of -2/3x, okay? And then of course we know very well that, look, this is plus or minus the square root. And then of course we know that x here must be less than or equal to 0. Of course this is the restriction, but now the question is here, guys, on which graph is this restriction? This restriction is basically on the parent graph. Okay, great. And we know that P is literally up here. So this means we shifted this up down here. such that our graph looks something like this. So our graph was going to be something like this. This is the graph of P. This would have been the graph of P. Okay? But now this is the graph of P, remember? Now this P, we were told that there is a restriction here. This restriction is on the original, because if you do not think about it that way, remember this one gets restricted on the Y. Remember, once you restrict the domain on the original, you are literally restricting the range on the inverse. Okay, so this means here, well, we are missing this side, because when we say x is less than 0, it means our P is only going for the negative portion of it. This is P of x. And what will be the inverse? Remember the inverse, these graphs are symmetrical about the line y is equal to x. This one is going to be doing something like so. So that would be the inverse, which is that P to the minus 1. That's an inverse. It looks like a crazy story there. Okay, so that is the inverse of P. So they always do that. And then of course they are symmetrical about this line, which is y is equal to x, which cuts them like that. Of course, you don't really have to show that line. I mean, I'm just trying to show you everything that is in there. Okay, so we are sorted, guys. We look sorted. We look sorted. Okay, so let's have a look now what is going on. The question says oh yeah, I think we are done. Now the question says we have to look, we said if we restricted the domain on the parent graph, then we're going to essentially restrict the range on the inverse. So this inverse function is basically going to be this one, the negative one, because it will have to carry the restriction that was given there. So this is minus 2 over 3x. This makes sense because when x is less than 0, we know that there will be no negative under the square root sign, but we just have to be careful to choose that negative, because if we are restricting the domain on the parent, we literally are restricting the range on the inverse. So these are some of the key areas, guys, to make sure you have mastered. Otherwise, this thing will become your master. Okay, not a problem. They said write down, so it's not a big deal. Okay, no, I'm looking at the wrong question now. So that was the question. And then now the next question says, folks, the next question says what is that? 3.8. It says, is that inverse a function? The answer is a hell yeah. Yay, o batla o reng wena? Ke batla ho tjho jwalo. Look at this. Always be comfortable doing graphs even if you're not asked, and be quick about it. So you can't still be looking for intercepts and then testing values. You need to know these shapes off by heart because of knowing the characteristics of these functions. If that is not your strong point, this is going to be a very painful exercise, I can assure you. And then of course, if you do a vertical line test on that function of ours, so if we just draw any vertical line for that matter, do you see it will cut at only one point on that graph, because we had a restriction on the parent graph, which is the red one. So if we didn't have a restriction, this one was going to go on in that way, and therefore it would fail a vertical line test. But now because of that restriction, it literally passes. So you can just write here, it passes. the vertical line test. You can even explain why, due to the restriction on the domain of the original function. But they don't really care for an explanation. You just say it passes the vertical line test and you are sorted. All right, you get your 2 marks for your yes and then for your explanation. Okay, now let's sort the last one. 3.9 says the graph of G is a tangent to h of x equals k over x and determine the value of k. Now the issue is, what is that, guys? When you have a constant divide by x and that is a function, that's a hyperbola, right? Right. That's a hyperbola. So, fine. We know that, well, we have an understanding that when we do the gradient at the point of tangency, the gradient of the tangent will be equal to the gradient of the curve of h at that particular point of tangency. So how do we explain this? We can say here, we understand that, well, h prime of x is going to be equal to the gradient of that function, which is going to be 3. Remember, the gradient of g was a 3, right? Remember that. Don't like this back and forth kind of business, but yeah, it's happening. So remember, that is the gradient. So we know that at the point of tangency, but remember, this is at the point of tangency. Okay, at the point of tangency, we know this is the case. Now let's do the derivative of this thing. This implies what? It implies that we have here k times x to the exponent minus 1. You always never derive until this thing is in line like that. It's going to be equal to 3. And then, of course, we want to do the derivative. In fact, I'm messing up. So this is the step that you do on the side, right? Because you want to write the derivative. So you multiply that in front, it becomes minus k times x to the minus 2 equals to 3. But anyway, I'm just not doing the right job here. No. Remember, we're doing the derivative here. So this is going to be minus k times x to the minus 2, which is the same as minus k over x squared, okay? So this is the derivative. So what do? You want to take this one and plug it up there, okay? So let's remove these ones because we don't want a complicated scenario here. So all we can see here is that we're going to end up with minus k over x squared is equal to 3, right? Right, and then of course this is 3 over 1. You cross multiply there, it tells us that minus k is going to be equal to 3x squared. Therefore, our k is going to be equal to minus 3x squared, okay? That is equation 1. Remember, you will need simultaneous equations here because this doesn't solve anything. We have 2 variables, so we are in trouble. What else can we do, misters and misses? The thing that we can do is that we know also that g of x at the point of tangency, we know that g of x is definitely equal to h of x because they're sharing that point of tangency. So what is g of x? Is 3x plus 6 is equal to h of x is just k. This is k, not x. Yeah, I'm learning, guys. K over x, maybe that looks a bit better. Okay, so now what do we do here? We know that our common denominator here is x. So if you multiply by x throughout, what do we get? We get 3x squared plus 6x. Ooh, my 6 is trying to die. 6x is equal to k. Now do you see? each one of these is equal to k, so you can make this one equation 2. You can say therefore what? I know that 1 is equal to 2 because each one represents k, which implies what? That minus 3x squared is equal to 3x squared plus 6x. Okay, that is what this is. And then of course we take that to that side, we get a minus 6x squared equals a 6x. Okay, so what we can do here, did they say values of k? They said the value of k. So what we can do here, we just simply divide by 6x, and then we divide by 6x, and then we tell that our x is going to be, now this one cancels and then that one takes that, so our x here is going to be minus 1. Okay, makes sense, ne? Our x is minus 1, not a problem. So if x is minus 1, I'm running out of space. I'm just going to try and finish it up here. So this implies that our k is going to be minus 3 into minus 1 squared, which means our k here is minus 3. Okay, great stuff. So our k is minus 3. Not a problem. So does it make sense? It follows therefore that our h of x is minus 3 over x. Does it make sense, guys? I think it does, because look at this. At the point of tangency, we have a positive gradient of 3, right? When does a hyperbola have a positive gradient? Let's just pick a spot and just work our magic. If you have, for example, a hyperbola that is in the second quadrant and fourth quadrants, okay? Of course, we can see the asymptote lines are the x-axis and the y-axis because it's not shifted, right? This one is not shifted. So, now remember all gradients here, all gradients to this line, if you draw tangents there, they will all have positive gradients. So it only happens when the graph is on the first quadrant and fourth quadrant. And this is the situation you see when a is less than 0. So this makes sense. So I can accept this one already. Okay. And then of course you want to test these things if it is indeed making sense. But I'm happy with this one at this point because, I mean, you don't want to be overzealous and waste time. So we can just leave this one alone. We just wanted to use it to see if any of this makes any sense. And it seems to make sense. Okay, guys, not a problem. So we're going to just keep this steam trade moving. So you can see how these marks come by, and you can tell that this was not an easy question. You had to think a bit. So that was a bit of a tricky question, but a question that you know how to handle in grade 12. All right, guys. Whew, let's just pause for a second. I need a drink. All right, guys, I've had my water and I am fresh again. So let's keep going. So we're looking at question 4. Question 4 says, in the diagram below, f of x is equal to 4 to exponent x. Okay, so I want you to have a look at that function. Always employ the skills you get taught. Now look at that. What is a here? A is basically equal to 1, which is a number greater than 0, right? Right. So a is greater than 0. So that means if a is greater than 0, our expression, or should we say our graph, is going to appear above the horizontal asymptote. And usually when it is not shifted like this, the horizontal asymptote is the x-axis. So meaning we want to see this graph above the x-axis. Okay. Now, what should it look like? Now, you consider the b. B usually, remember they can use any letter though. B basically represents the base of our power there. Remember the power is the base together with its exponent. So we're looking at the base of that power. Now, if you look at that, it's 4. This is a number greater than 1. Now, when you have this combination of a being greater than 0 and the base is greater than 1, it is an increasing function. So this means our graph is going up like that. So as you read it from left to right, it must increase. So that means this graph right here is our friend. It can't be anybody else but this particular guy. All right? Makes sense, ne? That is important to keep in mind. And then the next thing is, okay, I think we are done with this one. So we can see this graph is appearing above our horizontal asymptote. And of course, it's an increasing function because of the characteristic of that b together with the a. All right, not a problem. Then we have a function of g of x, which is also a hyperbola. So they kind of introduced a hyperbola upstairs there, and then they're bringing it downstairs. And then they're telling us though that there's a restriction to a hyperbola, that x must be greater than 0. So we can already see that this is appearing on the first quadrant. The other one would have been on the third quadrant. But because of that restriction over here, because of this restriction, so this graph does not appear here. Okay? But we know that for it to appear in the first quadrant and the third quadrant, it tells us that this a here, that a should be greater than 0 itself. Why? Because the graph is appearing in the first quadrant and was supposed to also show up in the third quadrant, but because of a restriction, we could not get there. Okay, guys, not a problem. We can keep going about our business. So this is our graph of G. This cannot be anything but that one. But if you look at these two graphs, don't you see that this graph here looks to be the reflection of this one about the y-axis? Definitely does at this point with this restriction. This is what it looks like. Anyway, that's just a look-alike kind of a situation. You don't want to read too much into it. Now we're told A is the y-intercept of f. Obviously, it's going to be at 1 because there's no shifting. Then P is the point of intersection of f and g. Not a problem. So let's chase these questions. Now the first question says calculate the value of A. Okay, what is A? Is on the hyperbola. So we start answering over here. Say 4.1. So we know that g of x is equal to a over x. And then through point P, which is that point of intersection, we always choose a point. It will be such that 4 is equal to a over 1. Therefore, a is 4. So this is done. They said calculate. You can't just show up with the answer. Please, guys, don't make the mistake. It has to show what happened. That substitution is important. Otherwise, you're going to get half a mark if you don't show those things. All right. You don't want to lose marks unnecessarily. Write down the equation of the inverse. Again, the question says write down. So you already know here the inverse of an exponential function is what? So we can say the inverse will be such that y is equal to the log of x to the base 4. Remember, when you have an exponential function like that, its inverse is a logarithmic function to the same base, by the way. I don't know what is happening. Please don't do things I don't ask you. So they said write down. So if you still are shaky about how to do the inverses, please, guys, double check. There's lots of videos on this channel. And there's also lots of videos on every other channel on YouTube that teaches maths. So also your textbook and your study guides are to be consulted where there is a doubt. Okay, let's keep moving, guys. We're doing fine. Now the graph of H is obtained when f is reflected about the y-axis. Okay, the graph of h, this is another thing now, is obtained when this is reflected about the y-axis, meaning it's a horizontal reflection. Now it says write down the equation of h in the form. Again, the question says write down. So this is where you just write down. Indeed, you are at liberty now to cut the corners here. But if you're still shaky about these things, remember when you're reflecting the graph of f, so we know here, I'm going to show you how it's done, but you don't have to show, you have to just write the final answer. But if you showed, it doesn't mean you're going to get extra marks. It is still okay to show. You may want to show it. I would advise you to show everything when you can, because you'll miss a mark somewhere and someone will feel like, you know what, you are justified where you started to show things a bit better. You might get that little mark. Maybe it would be the difference to getting that distinction and maybe that pass. So you don't want to leave anything to chance. All right, let's sort this one out. What is the story here? I'm looking for h of x. H of x is going to be equal to, I'm reflecting the graph of what? Of f about the y-axis. So it's going to be here the same as f at minus x, basically. That's what this means, which is going to be 4 to the exponent minus x. Okay, not a problem. And then, of course, if you want to get rid of this negative exponent, you can write it off like that, and then it becomes a positive exponent. But even if you left it here, it's still okay. You can leave it here, it's still okay. So this means you can just write h of x is either this or that. Not a problem. You are sorted. That's why it's just 1 mark. So you can leave it here. It's not a big deal. You can bring it down here. It's still okay. All right. Now it says write down the range of minus f of x. Okay. Again, 4.5. No, I'm in a hurry. 4.4. First of all, we know that minus f of x is going to be equal to minus 4 to exponent x. Okay, so this means we are reflecting our function about the x-axis. So this is a vertical reflection. Now, what happens when we reflect our exponential function about the x-axis? It does something like this. So when a is negative and yet our b is still a number greater than 0, our function is a decreasing function. So it does something like this. Okay, so this would be minus f of x. Okay, of course it will cut at minus 1 this time. So what would be the range? Remember, the range here was greater than 0. Now this one is going to be less than 0. So y is less than 0. So we can say the range is going to be equal to set of y values such that y is less than 0. Sorted. And then, of course, y can never be equal to 0. So this already sorts that out. Okay? Or some people like to say y is an element of 0. Wait. Start with the other stuff. Is an element of minus infinity all the way to 0, and 0 is not included. So you can write it like that. Or you can just write y is less than 0. Still okay. So here you've got a bit of a leverage. Again, it's just 1 mark. Now we are told if p of x is a function where g of x is translated. So which function is g of x translated 3 units downwards and 2 units to the left to form the equation of p. So now write the equation of p in that form. So which graph are we dealing with here? Is g. So what are we doing to g of x? We are translating it 3 units downward. So that means we're going to subtract 3 to the function and then 2 units to the left, then we're going to add 2 to the x there. So they're saying again, write down. The question says write down. It's not saying determine. So this is 4.5. So we can just say here, what is this we're looking for? P. P of x is basically g of x plus 2 minus 3. This is how you can start working this out. And then this simplifies to, what was a again? We found out that a was, did we calculate a? A was 4, yeah. So this follows that we will have 4 over x plus 2 minus 3. So this is the form that they wanted. So it's already in that form. So you're getting a mark for this part and then that denominator there. All right, guys. So time is flying. Determine the values of x for which. Now this is a very good question because it's one of those interpretatory questions. So let's just look at it down here. So we have ourselves here. These interpretatory questions, you don't have to show too much here. So let's do it. 4.6.1. So it says determine for which values of x is f of x minus g of x less than or equal to 0. Okay, obviously, let's have a look. F of x must appear above g of x. And then if we look at this one, f of x is above here. It has a positive y value and a bigger y value minus a smaller y value on this side. So we're going to get something greater than 0 here, and that is positive. But at the point of intersection, they are equal, so they will subtract to 0. So that point is important. But we can see that we can't go that way, because if we go that way, this one has a positive y value with a negative corresponding y value on the other function. So we're going to get a positive answer, so it doesn't satisfy our inequality. But if we go this way, you can see that this graph here is going to have a positive y value, so to speak. But remember, it never crosses this asymptote line. This is the most important because we have a restriction there. So that means 0 is also the limit to what we can do. Okay? And of course, it cannot be considered because it's an asymptote of our g. So let's have a look here. So that means these values lie here because look, this one is going to have a smaller positive y value with a bigger positive y value. So when you take a smaller positive y value and subtract a bigger positive y value, we get an answer that is less than 0. So we can say here, well, we know that x here must be less than or equal to. That point is included because there you get satisfied for 0. So x there is 1, right, at P. And then, of course, we have to know that x must be greater than 0 because this is an asymptote. So this is the region that we want. Not that one, actually. I'm lying to you guys. It's the region that we want. So we want something like that, of course, excluding the asymptote. Great. So this form, usually you get 2 marks for it. So it's usually as simple as that, 4.6.2. Now the inverse of f must be less than or equal to 2. Now remember, the inverse is a logarithmic function. So let's just do it. The inverse of f is a logarithmic function. So if this is 1 over here, the log function is going to be doing something like that. It is itself an increasing function. Of course, it will never cross the asymptote over there. So this is the inverse of f. All right. So what is going to happen here? We want this to be less than a half or equal to a half. Okay. And then, of course, we know here this is going to happen at 4, that it becomes exactly 1. Okay. So when do we want this to be equal to a half? This one forces us to solve, right? So let's look at that. The inverse here is what? Is log of x to the base 4 less than or equal to a half. Then when we convert to exponents, f must be less than or equal to, and then 4 to the exponent a half. And what do we do now? We solve this thing. X must be less than whatever that is. So let's see, what is 4 to the exponent a half? I don't really remember, you know. That's the square root of 4. Damn it. That's just the square root of 4. Why am I doing this to myself? So this is just 2. And then we know that, okay, a 2 over there, if that is a 2, then we'll be sitting at a half. And then, of course, we are saying it must be less than or equal to. So the feasible region here that we're looking for is either this portion or all the way. And then, of course, this is still less than a half. So do you see, these equations can be quite hectic, but it's nicer to solve at times. But you can do the graph and check, but a little bit of solving algebraically makes the difference. Okay, guys, so technically here you're getting 3 marks for this one, and then for this conversion, and maybe for the substitution. I think it makes a bit of sense. Yeah, but it's not over. We need to also capture the fact that there is an asymptote here. This one must still be greater than 0. It can't be equal to 0. Okay. For this to be valid, it still has to be greater than 0. I think that is where the third mark is coming from. Yeah, I think this is important. So sometimes when you solve algebraically, you get just one solution, but think about the graph. What is going on? When is this valid? So this value is less than 2, but cannot be to the limit of 0. Okay. Yeah. So you get your 3 marks over there. So that is most important. Last one. So 4.6.3. And then this next question says x multiplied by the gradient of g, okay, must be less than 0. So we can already tell here that, look, if we're focusing on the gradients on g, remember the gradients are already negative. So the tangents there are negative. So those gradients are negative. And now for us to get a product, because remember there's that restriction there, it still stands. Nothing was changed. So that means x must be a positive value, right? Because a positive number multiplied by these gradients here will give us a number less than 0. So basically here we can say here x must be must be greater than 0. All right. Yeah, technically this goes to infinity, right? Yeah, I think that is fine. We don't really have some kind of an interval that makes any sense at all. So we can just simply say, look, it means x must be greater than 0. That's all. I think that is all. It can't be equal to 0 because it's an asymptote. But these gradients are already negative because g prime simply says gradients of the hyperbola. And whenever the hyperbola has a value that is positive, it only has negative gradients. Okay, that is sorted, guys. So you get your 2 marks there and you walk away. I mean, there can be no limit to this extent, at least so far. All right, guys. I don't know. Yeah, this thing is tiring. So we are like, whew. Okay, so we've done our magic. So we are up to financial mathematics. The money. So those of you who hate money, well, you don't have a choice. Money loves you, but when you love it, it hates you. Okay, let's just get to this thing. Move. Okay, an amount of 86,000 depreciates to a quarter. Okay, it depreciates to a quarter of its value in 7 years' time. Okay, using the reducing balance method. Okay, so they're already telling you what you are to use here to solve. Calculate the annual rate of depreciation. Straightforward question here. 5.1, we know that P, is it P or is it A? Sometimes I forget these things. I think it's A is equal to P1 minus I to exponent n. So the formula is as simple as that. And then, of course, we depreciated to a quarter. Okay. So, what is a quarter of 86,000? All right. Let's do it. 1 over 4 of 86,000. Is 21,500. So we have 21,500 here equals, the original was 86,000 into 1 minus I, which is what we're looking for. And the n is 7 years. And then, of course, this thing is annual, so it's yearly. So you don't have to worry about a nominal interest. So it's not months or monthly whatsoever. And then here, what do we do, friends? We just simply divide this whole thing by 86,000. We divide by 86,000. In fact, we could have just removed this thing and just wrote a quarter there, because that's what we're going to get here. So this is 1 over 4 equals, now we have 1 minus I to the exponent 7. So whatever you do here, folks, I'm forgetting my maths now. Now you just take the square root, the 7th root. So if you have a 7 here and you want to remove it, because it's gonna hurt if you try anything else. Okay, so you just take the 7th root of everything there. Let's see, what is the 7th root of a quarter? The 7th root of a quarter, that's not true. Shift that one, yeah. I'm messing around. I'm going to get the wrong answers here. So this, you often want to write it the way it appears. So I'm getting here 0, 8, 2, 0, 3, 3, 5, 3, 5, 6 equals, and then of course this is going to be 1 minus I. Now we are sorted, so we can say therefore our I here is going to be 1 minus 0, 8, 2, 0, 3, 3, 5, 3, 5, 6. Let's do that. And then of course we take that from 1. And then it follows that I is going to be 0, 1, 7, 9, 6, 6, 4, 6, 4, 4. Okay, so therefore, which is also, you multiply that by 100, and then you get, well, to 2 decimal places. This is 17,9 7%. Remember, we always round off to 2 decimal places when there is no instruction as to how our answer should come about. Okay, guys, that is easy. 4 marks here. You substitute into the correct formula properly, and I think this, taking the root, the 7th root of each situation and boiling down to that, and the final answer is where you score your 4 marks. Okay, let's keep moving, guys. We don't want to waste time here. All right, the next question says, a father bought a house for 800,000. He takes out a bank loan for the full price of the house and agrees to pay monthly installments of 10,000 rand. So this is monthly installments of 10 gorillas. Is it 10 gorillas or is it 10 squad? Total, man. Total prati. So, and then we look at this one. A father bought a house for this one. Okay, that is basically the amount of the ace. The baby ace, man. That is the money that we're probably going to be looking for. And then, of course, he says now he takes out a bank loan. So this loan, he took this amount of 800,000, okay, for the full price of the house, and agreed to pay monthly installments of 10,000 on the loan, which incurred interest of 14% per annum, compounded monthly. That is important. Now, the first payment was made 1 month after the loan was granted. Okay, now it says show that the loan would be paid off in exactly 234 months. Okay, not a problem. So let's deal with 5.2.1. Okay, 5.2.1. Timeline is important, guys. I cannot overly emphasize this tool. It's so wonderful. So T0, this is when you're taking the loan, right? This is the 800,000 that we took. And then T1, we're paying a 10,000, okay? And then, of course, this continues all the way until here, Tn minus 1, and then Tn. Okay, you know almost the arithmetic sequences here. So when you don't know there, you know this is what is going to be happening there. So even here, you're still going to be paying 10 squad or 10 gorillas. I don't know what is gorillas. Squatters, whatever they are. Yeah, we're paying that one. Okay, so that is our timeline over there. Let's capture our interest rate here. So it's very important. So this is at 14% per annum. Monthly. Okay, so we don't have a problem. We're going to deal with this one. And then, of course, guys, what is important here? N is literally going to be 12 multiplied by x. That means that n over the Tn is basically 12 multiplied by x, because we don't know. We just want to find out. And they're telling us that that should be 234. So we need to find that one out. Of course, this is a present value calculation. Straightforward, guys. No issues here. So we know that the present value formula says we have x into 1 minus 1 plus I to the minus n. Close that thing. And then this is all divided by I. So you copy the formula as it appears, and then you start sorting things out nice and easy. I don't rush to substitute here because it causes a few issues. So I start working my formula. So this is over 1, and then cross multiply over there. So first of all, what am I looking for here? I'm looking for n. So to get n, I'm going to have to multiply that and divide by x. So all I'm going to be dealing with here, I'm going to have here a p multiplied by I over x is going to be equal to 1 minus this one plus I to the minus n. And yeah, now it looks a bit promising, ne? So look, I've cross multiplied and divided by x. Okay, now I got myself a bit of a breather. And then of course what we do here, folks, we just simply do our magics here. We just take this and transpose and take this one and transpose. This thing is always less than 1. So you don't have to worry about whether this is going to be negative. No, it's never going to happen. So this implies that 1 plus I to the minus n is equal to 1 minus p multiplied by I over x. Now at this point introduce logs. So you're going to have log. So do you see how nice this thing is? Yeah, man. 1 minus p multiplied by x over there. And then of course we're saying if we have this, so we're going to have minus n here. Icon. I'm moving fast, Buffett. I'm tired of this thing now. Minus n is going to be basically log of this number 1 minus p times I. Okay, that over x. The base is going to be this one, 1 plus I. Okay, now we can do our good factorize. In fact, n is going to be minus log. Now we're sorting out these things. The base here is 1 plus, the interest was 14, so this is going to be 0.14 over 12 because that is monthly. And then the number here, sekuvele kwamosheka nge kutheni ngimosheke msinyanga. Okay, let's start with the number. So this is 1 minus p. Remember that was 800,000. And then multiplied by the interest here is 0.14 over 12, right? It's the nominal interest. And then all of that segment divide by our monthly payments, 10 grand. And then our base here is 1 plus 0.14 divided by 12. So that is like that one, yes. So now we can just punch this. This is minus log, by the way. Sorry, guys. Multiplied by negative. So let's see minus, very well, minus log. Let's choose the complicated log. Okay, the base there is 1 plus 0.14 over 12. We get to the number there. It's 1 minus this fraction of 800,000 times 0.14 over 12. Yeah, it's a complicated calculation. That also divide by 10 squared. 10 squared. Okay. So what I'm getting, guys, is a value that says I'm getting so I didn't put the minus. So I'm getting 233,46. Okay, so obviously to the nearest this is approximately 2.34, which is exactly what they wanted me to show. So maybe let's just say equal to 2.34, because I mean you can't have a quarter of a month. So remember, n is an element of natural numbers, so you take to the nearest here. This is 34. So this is done. I'm not even gonna go into too much detail. This thing is exhausting. Next question. It says It says, suppose the father encountered payment difficulties and you only started payments 5 months after the loan was granted. Okay, that says, how much will the new repayment be if the loan is still to be settled in 234 months from the time it was given? Okay, meaning this gentleman on our timeline here, where's our timeline? Come on. So this means this man here only starts here at T5 to pay his first 10, whatever amount. Okay, now we don't know what this should be because now it affects, so we can just say X rent. So we don't know how much he must pay. He only started at T5. So that means none of these payments were made there, and none of these ones were made there, none of these ones were made there. So the amount of moolah that we paid now is just X. Okay, that is cool. So that means this 800,000 will accumulate some interest, but wait. So you see, the good thing about timelines, it makes life so easy. If we're starting at T5, how many months have we not paid? So this moves from T1 dash 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 to T4. And that means we've been accumulating interest on this loan the whole time. Because remember, usually when you're given a loan, you pay by the end of the next month, right? Yeah, or the beginning of the next month, sorry. So you start paying. Now, remember, we lapsed how many times? We're going to lapse 4 terms because we're going to start on the 5th term. So we need to first calculate how much interest did this one accumulate, and then we'll calculate our present value based on that compound interest, and then going forward using the present value formula, of course. So now we need to calculate how much he's going to pay. So basically, we know that, well, our present value formula will tell us that we're going to pay this X amount like this. Okay, all over I. Okay, but now what is that present value? That present value is itself going to be 800,000 into 1 plus 0.14 over 12. But remember, we're going to lapse 4 months, so we're going to say how much interest are we going to get for those 4 months. That is exactly the total amount that we're going to be using as our loan. And then this is going to be equal to X into 1 minus 1 plus 0.14 over 12 to the minus. Remember, now the question is, what will be our N here? So if we lose 4 months, that means from 234, we're going to subtract 4 months. So this is basically going to be minus 234 minus 4. Oh, yeah, it's happening again. So look, let me not even complicate it. But remember, if you've lost 4 months, so this means you're only left with 230 terms to pay. Okay, because you've already lost time. And then of course this is all over 0.14 over 12. Okay, so with this one, guys, you can already see what's going to happen. We're going to multiply that there and divide by this. So it follows that our X is going to be 800,000 into 1 plus 0.14 over 12 to the exponent 4 multiplied by 0.14 over 12. All of that divide by that expression, 1 minus into 1 plus 0.14 over 12. Now this time to the exponent minus 230 and close bracket. So we get our money. Now let's do this complicated calculation. So we have 800,000 give me 1,000 0.14 over 12 into the exponent 4. That is multiplied by this situation here of interest is so, and then all of that we are going to divide it by 1 minus this 1 plus. Yeah, this calculation can be difficult. I'm glad they allowed these fancy calculators to come to the rescue of somebody, because I tell you, these things will hurt. They will hurt if these things are not there. These things must be there. Lama same thing must be there. So guys, what am I getting here? I'm getting 10,505 rands 72 cents. Okay, so it makes a bit of sense. We're supposed to pay 10,000. So he accumulated 5,000 more on the payments by losing out those 4 months. So it sounds a bit reasonable. Of course, 500 is not something to be taken for granted. Okay, people were paid 350s by the government for this thing. So guys, this is how you can get those 13 marks. You can already tell that it's not too big, it's not too bad, but it is something that can be considered for, some action. Okay guys, let's just keep moving. We are almost there somewhere. So yeah, let's keep moving guys. So differential calculus, so we're going to derive from the first principles there. So 6.1 is what you all know. Sometimes I feel like I should skip this thing because why? So f prime of x is going to be f at x plus h minus f of x divided by h. This is what we call, say, Isaac Newton's quotient. And I've shown you when I discussed the parabola on how to derive this using a curve, okay? So it's nothing fancy, so you know what this is, okay? So we just jump ahead and start working, and then we're saying, okay, where we see x, we'll put x plus h. So this is going to be basically here x plus h minus x plus h all squared minus the entire function. Now this is x minus x squared. Oh, what a big crime, guys. Why are you quiet when I'm making such a big crime? You guys are dangerous. You let me make a crime here. This is lim as h tends to 0. If you don't say this thing, you are asking for trouble. So that lim has to come out, okay? It just has to come out. This is just the key area for this situation. Otherwise, everything else is just easy. X plus h minus x plus h squared minus into x minus x squared. Okay, this is all over h. So I just like to work this thing as a whole. You don't have to. Lim as h tends to 0. Then, of course, we sort this thing. Now, this is effectively x plus h minus into x squared plus 2xh plus h squared minus x plus x squared, okay, over h. This is lim as h who tends to 0. And let's see, what do we do here? So we have here x plus h minus x squared minus 2xh minus h squared minus x plus x squared. Now you can see here that a lot of guys are going to start doing a number on each other. First of all, this guy does a number to that, this one does a number to that, and then all we're left with here is the lim as h tends to 0 of what? Now what we're left with here, why do I smell trouble? Oh, there's h here. So there is h minus 2xh minus h squared over, whoa, this guy is becoming careless, that is over h, so this is over h. Okay, now we can take the common factor, lim h into 1 minus 2x, okay, minus h all over h. Then now these guys start to do a number on each other, and that number ends like this. So this time we drop the limit, so it's going to be 1 minus 2x minus 0, which is going to be 1 minus 2x. Okay, so it makes sense, right? Yes, it does, because when you derive by using the power rule here, you're going to get 1 minus 2x. Okay, so this is sorted. Not a big deal. Okay, so we go for 6.2. 6.2 says evaluate. So 6.2, we have the derivative in terms of x of this expression, 2x minus 3 into 1 minus x. Of course, this implies that dx, you first simplify what is inside. So this is going to be minus 2x squared, right? This is minus 2x squared and then plus 2x. So we're going to have plus 2x plus 3x, which is going to be plus 5x. And then we're going to have minus 3 times 1, which is going to give us a minus 3. All right. Yeah, maniac. So we can do our derivative here. So we just go and say this is equal to 4 minus 4x plus 5. And then, of course, the derivative of a constant is out. Of course, I tried to move quick here. There's nothing special there, guys. You just do the thing and you start moving. So 6.4, what is the story there? We need to do the derivative of y in terms of x here. Again, when we are given, maybe let's write it the way they wrote it, y is equal to 1 over 2x plus the square root of x minus 1 over x squared. So we first sort this out. This is half of x plus you change this one to an exponent. This is to the exponent a half minus, then this one is going to be x to the exponent minus 2. And then you can say this implies that dy over dx is going to be equal to a half plus a half of x to the minus a half. Okay, that's what is going to happen there when we take 1 and then plus 2x to the exponent. This thing, don't do this, man. I don't have the energy, you know. Look at this. Plus 2 to exponent minus 3. Okay, at times you don't want to overly do this thing. You leave it like this, okay? Just leave it like this. If your derivative is fine, you don't have to convert these to exponents. But of course, if you want, you can say dy over dx is effectively equal to a half. Into, this is gonna head plus yep, it's gonna be 1 over 2x to the exponent 2. Now man, let's not complicate our lives, guys. Leave this thing alone. It's done. There's no crime there. So all is important is just this conversion and getting the derivatives for 1, 2, 3. That's how you get your 4 marks. Easy. We move on. Phew, we are still going through this pain, but wait, yeah. It is painful, but we're going to do it. Question 7 says, in the diagram, the graphs of f of x is equal to minus a third of x cubed minus 5 over 2x squared minus 4x plus 8 over 3. Okay, so we are sorted here because they've given us the entire function. So our job here is just to find out what we can do about it. And then g of x is a straight line. So meaning if we find the turning point at D, we've effectively found the graph. And then of course a here is less than 0. So our graph starts as a decreasing function and ends up as a decreasing function. So this is what you should be able to attend to. And then of course the y-intercept is over there. Now it says where k is a constant, fine, are drawn. C and D are the turning points. We can see them on the graph. A and C are the x-intercepts. Yeah, we can see that. And then of course we see that this g of x is a tangent to this turning point, but not necessarily to the graph. Okay, now let's just get to the questions here. We don't want to spend too much time. It says show that the coordinates of D are. So we know, man, that 7.1 for the turning points, it is such that f prime of x is equal to 0, right? Right. And then we work it out by doing the derivative, which we just did here. So if you put a 3 in there, the 3 cancels, and then we remain with minus x squared. Okay, see how nice this is. And then this one, when you multiply 2, the 2 cancels out, there we get a minus 5x, and then minus 4 equal to 0. The constant falls off. And then of course we can factorize this thing. It's going to be minus x and x. 4 basically is going to be 4 and 1. But I want a minus 5, so this is minus 4 plus 1. No. I think this is incorrect. The signs are not correct. It's not going to get me back to where I want to go. So this must be positive because it will be affected by this negative. And then this one must be negative. Therefore, it works out. So it tells me, therefore, that x, of course, this is going to be the x at D, right? Is going to be what? When you transpose this, you get a minus 1. Or x at C, remember, it's going to be the smaller value, minus 4. All right. So we can say now, what would be the story when we put f at minus 1? What happens? I'm just going to put it in the calculator and not stress anything called me. But you can stress yourself. I don't mind. See, when you have fancy things that can relieve you of a little bit of a problem, you just do that, which you can do. 5 over 2 into minus 1 squared minus 4 into minus 1 plus 8 over 3. And I am getting a 9 over 2. So therefore D is the point minus 1 is to 9 over 2. So this is pretty straightforward, guys. No need for no problems here. Okay, so the next one says calculate the x-coordinate at B. So you can see that at B we have the same elevation as point D, meaning that value is the same. So we can say B is such that 9 over 2 is equal to minus a third x cubed minus 5 over 2x squared minus 4x plus 8 over 3. Okay, so it is just basically our lovely expression there. But we know that at B, we're going to have the y value of 9. Okay, what does this imply? Of course, what is the LCM here? So you multiply by the LCM throughout to just simplify your life. So the LCM is going to be equal to 2 times 3 is 6. Okay, so you multiply throughout by that LCM. What do we get? So when you multiply by 6, there 6 divided by 2 is 3. 3 times 9 is 27 equals. Here we multiply by 3, we get a 2. So we get a minus 2x cubed. And then when we multiply by 6, there we get a minus 3 by 5 is minus 15x squared. And then of course 6 by 4 is minus 24x. And then there we're going to add. So basically it's going to be 3 by 8, which is 24. Okay, I hope I'm not making a mistake. So no, it's 16. Yeah, so we're putting a 16 in there, running out of space. All right, this implies what? Now we can start working our magic here. We take this to this side, so it becomes 2x cubed, and then plus 15x squared, and then plus 24x, and then when we bring in 16 to that side, so we have 27 minus 16, we get plus 11 is equal to 0. But remember, we already know that this quadratic, when x is 1, minus 1, sorry, we get a 0. So let's just test it again and say here 2 into minus 1 cubed plus 15 into minus 1 squared plus 24 into minus 1 plus 11. Do we get 0? Yes, I get a 0. So already though, this key point already tells you that when the y value is this becomes the root. So we know that this implies that we have here, if we say minus 1 there, it means x plus 1 is a factor. So we can do this by inspection. So you don't want to sweat your brain here. You are going to ask yourself, what must you multiply this with to get that? It must be 2x squared, right? Right. What must you multiply the 1 with to get 11? It must be 11 plus 11 even. And then now you focus on any one of these two terms. What I would like to, I always choose the simpler one, but I mean still okay, whatever you think you can do. So basically I'm going to multiply this, there becomes 11x. Okay, so what must be here to add up to 24? So let's see, 24 minus 11 is 13. So basically it means I must have a what is that? I must have a plus 13x there, because now when I multiply that and then that, they will add up to 24. Let's see, what about 15x squared? This happens when you multiply x, that becomes 13x squared plus 2x squared, it gives us 15. So this is sorted. This implies that x plus 1 into, we can further factorize this thing. It's going to be 2x, then it's going to be x. And then now factors of 11 is unfortunately 1 and 11. So where must the 11 be to avoid problems? 11 must be here and 1 must be there. So again, everything is positive. So this works out because 2 plus 11 is 13. We are sorted. You can see there's equal roots here. So therefore x is equal to minus 1. There's equal roots here. Or x is going to be equal to minus 11 over 2. So what did we want? The coordinates of B. Therefore we can say B is the point minus 11 over 2 is to 9 over 2. Of course, this is just how you do it. I've done my factorization by inspection because it saves me time. But you can do it by what you call using the synthetic division or the factor theorem. I'm not even interested in where the marks are at this point. Sekulate kakhulu bafethu, so you will forgive me for not showing. Just go and find the memo whenever it gets published and see where the marks could be obtained if you approach it this way. Now it says, for which values of x will f be concave down? Okay, now remember, usually it says find the point of inflection. Maybe it's over there. So what is the point of inflection? Obviously, the point of inflection is always halfway between, the x coordinates are always halfway between the turning points. So we saw that this is -1. We saw also that this is, what was the other turning point, by the way? I kind of didn't focus here. Here when we got a -4. So this is -4. Okay, so if you sort out these two, you can say here, you add the 2 basically, you become 5. It becomes -5/2. Okay, so this is fine. You can just use the graph here and say x must be greater than, remember for concave down, actually it must be less. So when what do you mean concave down? It must be greater. Hey, when? What are you trying to do? It must be greater than the x at C plus x at D over 2, which implies that x must be greater than x at C is -4 minus or plus -1 over 2. Therefore, x must be greater than -5/2. This is sorted. You don't want to complicate your life here, doing first derivatives and doing second derivatives, but you can, even if you do it that way. When you do the first derivative, remember it's going to look something like that. Then, of course, the second derivative here. Remember, for a graph to be concave down, it means the second derivative must be less than 0 initially. And then what would be the second derivative? There's -2x minus 5 must be less than 0. Transpose here, you will get -2x less than 5. And then you divide by 2. So you get x. When you divide by negative, the sign changes. It becomes now greater than -5/2. So do you see it's the same thing? It's the same thing. So you can use the derivative, you can use the graph. Whichever sounds like it's working, you use it. Ne? Yebo. Yebo. All right, matriculants, we are really doing great. Yeah. We're getting somewhere. And then now it says, determine the equation of the straight line that is perpendicular to the graph of f at point A. So these guys, hey, they are not tired. Come on, guys. So please, man, get tired a little bit. So we know here that we want a tangent first at point A, because this line, whatever it is, it has to be perpendicular to our tangent at A. The tangent gives us the gradient at point A. So this is basically the idea. So that line is going to be something like that. Now, what are the coordinates of A? Did we ever look for them? We may have to, oh goodness, they gave it to us, so they made our life a little bit much easier. Okay, so first of all, we want the gradient at point A. So we can say the gradient, what is the story? No. We can say now the gradient of the line multiplied by the gradient of the tangent at A must be -1, right? These are perpendicular lines. Great stuff. So now, what do we know? Well, we know that, fine, this is the same as saying the gradient of the line, let's just say the perpendicular line, let's just say gradient of perpendicular multiplied by. So how do we get the gradient at point A? We just take the first derivative and put our thing is there. So this is the same as multiplied by f prime at that point, a half, must be equal to -1. Right, so this also follows that the m of the perpendicular line multiplied by, okay, let's just say bracket, the bracket is much better here. So we're going to have, what was that derivative there? It was minus x squared. So we have minus into a half squared minus 5 into x, which is going to be something like that, and then minus 4 is equal to -1, which also implies that m of the perpendicular line multiplied by, now we can sort this out. So this is minus into a half squared minus 5 into a half minus 4. And that, but it's a negative gradient. I'm grateful. This is multiplied by minus 27 over 4 equals to -1. Therefore, the gradient of the perpendicular line is going to be a positive gradient. Can you see? It makes sense because this tangent was negative. That one becomes a positive gradient. So remember, when you divide by fraction, you flip it over, so it becomes 4 over 27. We can say this implies that the line, the perpendicular line, is such that y is equal to 4 over 27x plus c. And then through point A, which is a half, is 2, 0. It will be such that 0 is 4 over 27. Oh, what am I doing? Into a half. Yeah, plus c. Therefore, our c is going to be... Okay, so let's see what is going to happen here. We're going to have here 4 over 27 times a half. So this is 2 over 27. And when we transpose that, it becomes minus 2 over 27. Okay? So this is fine. So therefore, the line is going to be 4 over 27 minus 2 over 27. Yep, it makes a bit of sense. The numerator is even, the denominator is odd, so I think it's fine. Of course, I may have mishandled some things there. You just make sure you double check, but this is how you think about it. You do a bit of a sketch on your graph and then you use the information that you have. All right, so we are sorted, guys. So can you see these questions icon? They were kind of fighting with you guys. You are like the Northwest guys. You are getting punished as much as possible. But it's okay. Punishment is a part of living, right? It's a part of life. Okay, let's quickly wrap this thing up, guys. We are almost at the point of finishing this thing. So let's have a look here. A hat box in the shape of a cylinder is to be constructed in such a manner that the sum of its height, remember the sum is the addition of its height and the radius, gives us 6 units, okay? And then they're giving us the formula there for the volume, which is pi r squared h, of course, because it's a cylindrical prism. So this is the shape that they're giving you. That head, this is the part that they want you to focus on. All right, not a problem. So it says now show that the volume of this little thing here is written by that. Okay, let's just jump in. 8.1. We know that the volume is going to be, of course, pi r squared multiplied by h. But now, do you see there's no h in there? We can say, but what, mister? We were told that the sum of h and the radius is 6. So we can then substitute h is going to be 6 minus r. Okay. Then we put it back, which implies now that v is going to be pi into 6 minus r, and then we square that thing. Wait a minute. What are you doing? So this is r squared into h is 6 minus r. So when you multiply by pi r squared here, we get 6 pi r squared minus, and then of course we get pi r multiplied by r is going to be r cubed. So which is exactly what they said we must show. So that is sorted. 8.2. It says now determine the radius for which the cylinder has the largest possible volume. So the largest possible, basically we can say for maximum volume, it implies that the v prime in terms of r, because I mean you can see the variable there, that is you can say v prime in terms of r is equal to 0. It's not really coming out the way I want. So it means v prime in terms of r, not x, is equal to 0. Okay? So what does this imply? It implies now that when we do the first derivative, that becomes 12 pi r minus 3 pi r squared is equal to 0. And then we are like, thank you very much. We can take 3r. Remember here when you factorize, you take the highest common factor to make life easy. So what can go in here is 3 pi r. Wonderful. So now what we remain with here is 12. No. This is a 4. So remember 3 by 4 is 12 pi r. Sorted. Minus, and then here we took out 3 pi r, so we remain with r equal to 0. That one already disappears. It tells us that our r is going to be 0, or our r is going to be equal to 4. So obviously r cannot be equal to 0. Talking about measurement of a volume cannot be 0 here. So this implies, or it says determine the radius. So this is basically 4 units. Therefore, the radius is equal to 4 units. Sorted. So again, the good thing here is that you needed to sort of do the derivative. So this is where you get your marks, and then that marks there. You're getting it, and then for the mathematical gymnastic there of doing your factorization by looking for the highest common factor, and perhaps rejecting that, I'm not too sure, but I wouldn't really bet on that. I would say perhaps that statement is key. Then doing the actual derivative and some gymnastics there give you the answer. So there you get your 6 marks. Okay, guys, we are almost at the end. Do you see? If I wasn't explaining, I could make it to 3 hours. So we're doing this for 2 hours. So almost on the 3rd hour. So do you see? You can really thrive if you are doing your things right. So let's look at question 9. 9.1 says it is given that A and B are independent events. Of course, probabilities. Once you hear independent events, it means the probability of A and the probability of B are equal to the products of those individual probabilities. So using the product rule here, once they say independent, it means A and B are going to be P of A multiplied by P of B. So that is what independent events mean. Then of course it says calculate the probability of A or B. So we're going to use the addition rule here. P of A or B. Okay, let's just pause for a second. All right, guys, let's get to it. So now this is going to be equal to, of course, we're going to use the addition rule here. It's going to be P of A plus P of B minus P of A and B. Okay, so this is sorted. So because P of A is basically 3 over 8 plus that one of B is a quarter minus this one is going to be 3 over 8 times 1 over 4. So this one is simple. You just sort it out. Bodmer style. First deal with the multiplication and then the signs. Addition and subtraction is more or less the same thing, but your calculators are already smart. So you don't want to worry too much. Minus, here we have 3 over 8 multiplied by 1. Ooh, 1 over 4. So my brain is a little fried, my friends. Is a little fried, my friends. So this one I'm getting 17 over 2. Oh, 32. Which when you take down, so you can say, I'd rather leave it here. Okay. You can express probability as a fraction. You've already expressed it as a fraction, so leave it alone, please. Don't complicate your life. It's just nothing here. You see 3 marks. The first mark comes here, and then the other mark comes from the answer, and the rest is the general substitution. You see? Sorted. No issues here. So let's look at 9.2. It's a different story now. 9.2 says, the probability that it will not rain, so not rain, on a given day is 37%, okay? And then they're telling us here, a child has a 12% chance of falling in dry weather and 3 times. Okay, now this falling here follows dry weather and then is 3 times likely to fall in wet weather. Okay, so this is easy. We just handle it. It says now 9.2.1, draw a tree diagram to represent all the possible ways which the weather could affect whether a child falls or not. Show the probabilities associated with each branch as well as the outcomes. Okay, so first of all, 9.2.1, we can answer it this way. We start, of course, by saying the rain situation. So now it says the rain, it says the probability that it will not rain on a given day is 37%. So we can say R prime, not rain. So we have 37%. Remember, probability can be expressed as a percentage, so it's not a problem. So if it is 37%, what are the chances that it will rain? Now, you're going to take that from 100%, right? Because it must give us 100%, which is effectively 1. So minus 37 there. So this means there is a 63% chance of rain. All right. And then now we're going to peg this with this child trying to fall here. All right. And not trying to fall. So the child may fall. Okay, maybe if we have that one, we can say not fall as well. Let me see. Yeah, in dry weather, so we can say not fall and then fall. Come on, F. Don't do that. So we can say not fall. We can say fall. All right. And then, of course, here the outcomes are going to be no rain, no fall, no rain, fall, rain, not fall, rain and fall. Okay, so these are the outcomes basically. All right, so that is it. So let's just separate them from this thing. So these are the possible outcomes. Maybe you're too close to the line, so we can say here it can rain and the child falls. So they're telling us here that the child has a 12% chance of falling in dry weather. So there is 12% here chance. All right, and then of course, if you think about it, if this child has a 12% chance of falling in dry weather, and then what is the chance of not falling in dry weather? So that should be from 100 as well. Remember, this is packed here, so it should be 100 as well minus the 12%, which becomes he has an 88% chance of not falling in dry weather. Okay, come here and say, well, what are we going to do here now? They are saying here the child has 3 times likely. Remember, when they say 3 times likely to fall in wet weather, remember, if he had a 12%, so you just multiply that 12 by 3, which becomes a 36. So this child has a 36% chance of falling in wet weather because it's raining and then the child falls. Okay, and then what are the chances of not falling? Again, it's going to be 100% minus 36%. So this one has a much bigger chance of not really falling. Okay, so it's not too bad. So I think this is exactly what they want here. And then of course these outcomes, I don't know if we can calculate them, because remember the outcomes, you just multiply the arms. So we have 37 times 12. So do you see that is ridiculous? It gives us something like yeah, this one is terrible. It gives us 444. Now do you see that is not quite good? That is not quite good. So I don't know, man. Maybe I did something wrong, but ke tla itloela hona mona. Yeah, I'm leaving it here, bafowethu. I'm leaving it here. Maybe this percentage, we can represent it as a decimal. So 12 over 100 makes a bit of sense. It's 0.12. Maybe it makes a bit of sense, and then when you multiply by 0.37, and then we get a 0.044444. But in any case, it just does the same thing that we were doing here. So when you multiply by 100, that thing here, we get 4.44%. I don't know if I'm answering this correctly, but I believe it is correct like that. Maybe the possible outcomes is that. So I don't think they want the percentages of the outcomes. Maybe not. I don't know. Probability can be expressed as a percentage or as a what you call a fraction. So basically, if we have here 0.13 and then we take that from 1, it is definitely 0.879, 0.37. So this one is 63% or 0.63. I mean, you can leave it as percentages or you can put decimals. It's still okay. So I think this is sorted. These are the possible outcomes. And then, of course, you simply multiply. Remember, these are independent events, so to speak. Okay, maybe they are dependent. Who cares? But this is another situation and another situation. So when you want the probability of this, you multiply those probabilities. It's just as good as that. So we leave that thing alone like that. Yeah, we leave it alone like that. We don't want to complicate. Let me try here and say 37%. times 12%. What do I get? Yeah, I get a very strange number here. It becomes a 0,044444. I think you can leave it, but let's just write it in case they want it. I don't know when they say show the outcomes. Nancy can go and tell. And if I felt we're doing so well, I don't want to take longer than long, you know. So now it's starting to irritate me. So this is 0,0444. Okay. And then this one is going to be 37% multiplied by 88%. So this is basically 0,3256. And then of course this one is going to be 63% multiplied by 64%. That is something. So I'm getting 0,4032. Okay, and then this last one here is gonna be 63% multiplied by 36%. Of course, you guys have fancy calculators. They can simplify your lives and give you all these values. 0,2268. Okay, great stuff. All right, guys. So, I mean, I don't know if I'm really going too far, but it's fine. We are just doing what we have to do. And then the question says now, 9.2.2. It says now the probability that the child will not fall on any day. Okay, that means both rainy and not rainy day. Okay, so let's see the part that says not fall. It is this part here, and then this is this part as well. So this means here we want the probability of the child not falling. So this is effectively what is that? This is effectively the probability of, say, R. Remember, this is R dash and F dash. This is not falling, right? Hey, it looks like I made a mess now. They are saying the child has a 12% chance of falling in dry weather. So this is falling, bras. Okay. And then this one is not falling. Okay. Yeah. So 12% chance of falling in dry weather. So that is falling, not falling. So this is the story right here. So this is now dry weather and falling. Okay, so that is sorted. And then of course, let's just double check that everything is correct. It's easy to make a meal of everything when it's too easy. And then, I don't know now. This is 3 times likely to fall in wet weather. Okay, that's fine. That is fine. I think this one is correct. I just messed up a little bit there. So, yeah, I think that's fine. They said 12% chance of falling in dry weather. This is not rain and falling, not rain, not falling. This is rain, not falling, rain, falling. Okay, great. Doesn't really matter how you put it. So what do we want? We want dry weather and not falling. Okay, great stuff. Or, where else can this be? It can be here. It can be wet weather. So it is R and still not fall. Okay, so when you have probabilities like that, you add the probabilities. So you those outcomes, I think they are important. So we can just put them in there, and then we have here 0, comma, can I even read this thing? This is 0,3256 plus, and then we're going to add here 0,4032. Okay, let's do it. 0,3256 plus 0,4032. Okay, so what I'm getting here is 0,7. Let's just say 2. But you know what I prefer here is just to leave it as a fraction, because I'm trying to run away from problems. I'm getting 911, 12,050. So that is exactly what you do. In fact, it's not 12,050. This is 1,250, right? The American style, or 1,250. Okay, guys, I think this is it. Of course, you can express it otherwise, but I think I'm running away from the issues that this thing is going to bring. Okay, guys, that is it for that question there. Let's just run to the last one. Oh, finally. Okay, so you can see that I had some, say, 15 minutes to spare. So, I mean, if you don't explain anything to anybody, you're not talking too much while you do this, you just simply go for it. All right. So 9.4 says 6 learners, how many? 6, are to be seated in 6 chairs placed in a row next to each other. So we have 1, 2, 3, 4, 5, 6. Then now they say 2 of these learners are close friends, okay, and requested to sit next to each other. So let's just choose these ones and say these are the ones. I mean, they can be anyway. So these are the ones that need to sit next to each other. And then it says calculate the probability that these 2 learners sit next. Calculate the probability that these 2 learners sit next to each other. Okay, great. So basically what we have here, first of all, these learners need to be 1, 2, 3, 4, 5, 6. I think here these learners literally have to sit in 6 factorial ways, basically. Am I answering every question properly? Why do I have 9.4? Where is 9.3? Ish, you see this guy. You see this guy. I am too erratic here. Asan. I skipped 9.3. Okay, we will sort it out. Not a problem. Okay, so let's have a look here. These learners, if they are going to sit next to each other, they are going to sit in 6 factorial ways, right? Yes. This is when we don't have the restriction. Always think about it. If nothing was mentioned, that means the total here is 6 factorial. And then, now when they have to sit in a row, now we know that when they are to sit next to each other, we have 2 and 1, once we've picked there. And then what is else here? Then the others are going to sit here, like that. So we're going to have here, those 2 are out, so we're going to have 4, 5, 6. Oh, what am I doing now? Here when 4, 3, 2, 1. Now the question says here, calculate the probability that these 2 learners will sit next to each other. Okay, so if these 2 learners are to sit next to each other, we know that we're going to have a situation here of 2 factorial, which is for these guys, multiplied by, what is that? Remember, these learners can be here, they can be there, they can be here, they can be there, they can be there, they can be there. So how many possible ways? It's 1, 2, 3, 4, 5, okay? So there's 5 factorial ways in which these learners could be placed, okay? just forget about that at this point, because you just consider this as a single unit. So we have 5 factorial ways multiplied by that 2 factorial for them to sit next to each other. This is going to be over the total of 6 factorial, which is the random way of sitting next to each other, but not necessarily in that. Okay, I'm just going to say PE here for the event is going to be like that. And then let's sort this out, nice and easy. Well. Ish, I'm tired now, eh? Yeah, you guys probably feel like you've been hit with a stone by the time you are done with the exams, eh? I can already feel it too. So here it is 1 over 3, okay? So this is very easy, guys. So you always have to think about how, if they don't say too much restrictions and then further restrict, you know that the first stance is when they sit randomly. And then now you're going to focus on this restriction. But this restriction is going to trick you a lot, because here you may want to say 2 factorial multiplied by 4 factorial. But remember, you're going to have to multiply that by 2 as well, so to speak. So let's see if it makes sense. 2 factorial multiplied by 4 factorial multiplied by 2 divide by 6 factorial. Yo, it's not the answer that I'm getting. Hey, it looks like it's a mess. Hey, let's leave that one alone. Maybe I'm not very good with my adjustments, but this is the safest, because you're just going to consider that as a unit, but put a factorial into it, and then you know that there will be 4 spaces left. So it's going to be 1, 2, 3, 4, 5. So it can be 5 factorial ways multiplied by the 2 factorial, which is just 2, you know. And then over the total when everything is random, which is 6 factorial, and then that's it. So I think you're getting a mark for this guy, a mark for that guy, and a mark for that guy, because you had to find it yourself and then the final answer. That's how you get the 15 marks there. Okay, guys, let's sort this guy that I failed to sort out because I started getting too excited. I think I forgot this question. So let's insert 9.3 here. So 9.3 says you have to choose a password, okay? The password must be in the format 3 digits. Okay, digits are from 0, 1, okay, let's not even put decimal. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are actually 10 in total. And then what else? 2 of these superb. The password must be in this format: 3 digits followed by 2 vowels. Okay, vowels, remember, it's R, A, E, O, U. That is when we learned how to speak Bafwet and Mingangan. How many are they? 1, 2, 3, 4, 5. So there are 5 in total, the vowels. Okay, so you think about it that way. And then of course they're saying now here we're taking 3 digits. So there's a digit space here. And then we're going to have 1, 2, 3 slots for the digits. And then what about vowels? So we're going to have how many slots? They're saying how many? 2 vowels, okay? 1, 2. And then they're saying here where 0 is not allowed. So this one is out. So we remain with a total of 9. Okay. Okay, and all vowels are allowed. Okay, that's not a problem. Now it says you may repeat any digit. So the digits can be repeated, but you may not repeat vowels. So you see there's a lot of restrictions here that you need to think about. Okay, now it says how many passwords can be formed. This is fundamental counting principle. So of course, how many digits you have here? We have 9 in total when 0 is excluded. And then of course for this first spot we have 9. But remember, we are allowed to repeat. So we still have 9. And then we still have 9. So we're multiplying these things here. And then that is multiplied. But vowels, we don't repeat. So we have 5 options for the first spot and 4 options for the second spot, and that's it, because we can't repeat. So now the total number of ways is going to be 9 cubed multiplied by 5 multiplied by 4. Let's see, 9 cubed times 5 times 4 is a very huge number, but not too bad. It's 14,508 different ways. Okay, different passwords. Okay, so there it is, guys. See, I took an extra 20 minutes because I'm talking too much here. Otherwise, I know when you are doing this, you can see you can finish writing everything, but still applying your knowledge as you analyze these questions and sort them out. So I hope everything was clear, guys. If you pick up any issues, please let me know. Otherwise, I would say good luck with your preparations, and of course good luck with your exams. Of course, I'm still going to do paper 1 from the Northern Province. Is it Northern Cape? Yeah, Northern Cape. There was a request by another student there for me to do that video, so the next video will be on that one. All right, so we'll try this week to wrap up everything. Okay, I'll try to make sure I push for that. All right, guys, thank you for your patience, for watching this video to the end, and I hope you're going to like it. You're going to give it that thumbs up, and you're going to subscribe if you are new to the channel. And by the way, welcome. You're going to learn, and you're going to learn for sure. All right, and then of course, yeah, you can share it with the rest of your peers so that they too can see how things get done. And then of course, where there are issues, be sure to interact with me. Either you comment on the comment section down below, or you can email me. I will place a link in the description box of my email, so you can email me whatever correspondence you may have in mind. Otherwise, bye bye for now.